The use of data analytics has been rapidly growing with companies looking to generate insights and drive their business with the help of data. Hey everyone, welcome to this full course video on data analytics. In this video, we will learn data analytics from scratch and analyze data using Python and R programming language. We have our experienced instructors Richard, Avijit, Akshata and Shruti who will help you learn data analytics in detail. In this video, you will learn what is data analytics and why data analytics. We'll look at the different types of data analytics and see the various applications of data analytics. Then, you will understand a case study and perform analysis of data using Python and R. After that, we'll see the top 10 data analysis tools and understand the difference between a data scientist and a data analyst. Finally, we'll look at the top interview questions that will help you crack a data analyst interview. We will learn all of these under 5 hours. Over to Richard now.
Welcome to Data Analytics using Python. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. So we're going to cover data analytics with Python. We're going to go over what is data analytics, applications of data analytics, types of data analytics process steps, why Python for data analytics, and then we'll dive into use case demo so you can actually see some script and actually see what it looks like in the Python code. What is data analytics? Data analytics is a process of exploring and analyzing large data sets to make predictions and help data-driven decision making. Now, the definition of large data sets keeps changing, and so this can range really from just about anything to anything. But usually in today's world, we're talking significantly larger amounts of data that you can't just glance at and try to figure it out yourself. And the two steps are analyze the data and then make decisions based on the data. Applications of data analytics. Now, the sky's the limit on this. In today's world, almost every business act of life, your music on your Spotify, are driven by data analytics. But some of the big players, when you go in there job hunting, are going to be your fraud analysis. If you want to go make a lot of money and you're good at it and you like dealing with numbers, go join the banks and track down the criminals who are stealing money. It's a lot of, it's a big thing to protect credit cards, protect sales purchases, bad checks, any of those things when you can track them down is huge. Healthcare, exploding. There is everything from trying to find cures for the COVID virus or any of the viruses out there, using your cell phone to diagnose different ailments. That way you don't have to go in and see the doctor. You can actually just go in there and take a picture of the funky growth on your arm. Hopefully it's not too big. And then they send it in there and the data analytics goes in there and looks at it and says, oh, this is what this is. This is a professional you need to go see or don't need to see. And that's just one aspect of healthcare. The databases being generated by healthcare and getting the right doctors and helping the doctors analyze whether something is benign or malignant, if it's cancerous. All those things are now part of the ongoing healthcare growth in data analytics. Inventory management. Think one of those huge warehouses where they're shipping out all the goods. How do you inventory that in such a way so that you maximize the stuff that's being purchased the most near the entrance and all the other stuff towards the back, or even pre-ship it. So it's huge to be able to manage your inventory, and pretty soon they'll just have a drone come in there and start picking up some of those boxes and move them around also. Delivery logistics. Again, this goes from getting from point A to point B. You can combine it with our inventory, so you pre-ship stuff if you know a certain area is more likely to purchase it. How do you get the delivery to the most destinations the quickest in the short amount of time? And then they even pre-stack the trucks going out, and that's all done with data analytics. How do we stack all that stuff so it comes out in the right order? Targeted marketing, huge industry. Any kind of marketing, whether you're generating the right content for the marketing, who are you targeting with that marketing, researching the people, what they want, so you know what products to market out there, all those things are huge. And these are just a few examples. You can probably go way beyond this, from tracking forest fires to astrology and studying the stars. All of this is part of data analytics now and plays a huge role in all these different areas. City planning is another one. You can see a nice organized city like this one where you can get in and out of the neighborhoods if you're a fire truck. Police officers need to be able to get in and out. You want your tourists to be able to come in, yet you still want the place to look nice, and you have the right commercial development, the right industrial development, like enough residents for people to stay. All those things are part of your city planning. Again, huge in data analytics. So, sky's the limit on what you use it for. Let's take a look at types of data analytics. And this can be broken up in so many ways, but we're going to start with looking at the most basic questions that you're going to be asking in data analytics. And the first one is you want descriptive analytics. What has happened? Hindsight. How many sales per call ratio coming out of the call center? If we have 500 tourists in a forest and you have a certain temperature, how many fires were started? How many times did the police have to show up to certain houses? All that's descriptive. The next one is predictive. Predictive analytics is what will happen next. We want to predict. This is great if you have an ice cream store and you want to predict how many people to work at the ice cream store on a certain day based on the temperature coming up in the time of the year. And then one of the biggest growing and most important parts of the industry is now prescriptive analytics. And you can think of that as combining the first two. We have descriptive and we have predictive. And then you get prescriptive analytics. How can we make it happen? Foresight. What can we change to make this work better? In all the industries we looked at before, we can start asking questions, especially in city development. There's a good one. If we want to have our city generate more income, and we want that income to be commercial based, what kind of commercial buildings do we need to build in that area that are going to bring people over? Do we need huge warehouse cells, Costco sales buildings, or do we need little mom and pop joints that are going to bring in people from the country to come shop there? Or do you want an industrial setup? What do you need to bring that industry in there? Is there a car industry available in that area? If it's not a car industry, what other industries are in that area? All those things are prescriptive. We're guessing. We're guessing what can we do to fix it? What can we do to fix crime in an area with education? What kind of education are we going to use to help people understand what's going on so that we lower the rate of crime and we help our communities grow better? That's all prescriptive. It's all guessing. We want foresight into how can we make it happen? How can we make this better? And we really can't not go into enough detail on these three, because a lot of people stumble on this when they come in and are doing analytics. Whether you're the manager, shareholder, or the data scientist coming in, you really need to understand the descriptive analytics, where you're studying the total units of furniture sold and the profit that was made in the past. Here we go into predictive analytics, predicting the total units that would sell and the profit we can expect in the future, gear up for how many employees we need, how much money we're going to make, and prescriptive analytics, finding ways to improve the sales and the profit so we can sell maybe a different kind of furniture. We're going to guess at what the area is looking for and how that marketing is going to change. Data analytics process steps. So let's take a look at some of the basic processing and what that looks like when you're working with this data. So there's 5 basic steps. The 5 steps of processing, and this changes, and then there's a lot of things that go on when they talk about agile programming. The whole concept of agile is you take some kind of framework like this and then you build on it depending on what your business needs. So the first step is data collection. And usually with a large company, you might have somebody who is responsible for the database management. You might have another one where they're pulling APIs and they're pulling data off of maybe the Census Bureau, maybe something very, very specific, domain specific. So if you're analyzing cancerous growths and how to understand them, then the data collection is going to be those measurements they take from the MRI. Or it might be even the MRI images. They've used those also. So there's a lot of things with data collection and how to control that and make sure it has what you need and is clean and you don't have misinformation coming in. Once you have the data collected, there's a data preparation. So stage 2 is we take that data and we format it into something we can use. Probably one of the biggest formats that you see is when you're processing text. How do you process text? Well, you use what they call a one-hot encoder, and each word is represented by a yes-no kind of setup. So it'd be like a long array of bits. That's one way to prepare it. And so, bit number 1 is the. Bit number 2 is has, or whatever it is. Other preparations might be, if you're using neural networks, you might be taking integers or float numbers and converting them to a value between 0 and 1. That way you don't have one of them creating a bias in there. So there's a lot of different things that go into data preparation. That is 80% of data science. So when we talk about the data analytics, which is a little bit more on the math side, and they usually talk about a data scientist kind of being the overall preparer of this stuff, you're going to spend 80% of your data preparation. Data exploration, that's the fun part. This is where you're exploring things. And it is maybe 10 to 15% of what you do with the data you spend with the data exploration. It is probably the most important step, because this is where you got to start asking questions. If you ask your questions wrong, you're going to get some wrong information. If you're working with a company and they want to know the marketing values, then you really got to focus on, hey, how do we generate money for this company? Or fraud, how do we lower the fraud rate while still generating a profit? 4, data modeling. This is where we start actually getting into the data code, which model to use that predicts what's going to happen. And then result interpretation. We want to be able to interpret those results. You usually see that in your Matplot library, where you create nice, beautiful images so that it shows up on their dashboard for the marketing manager or for the CEO, so they can take a quick look and say, hey, I can see what's going on there. You want to reduce it to something they can easily read. They don't want to hear the scientific terms. They want to see something they can use. And we'll talk about that a little bit more when we start looking at some of this in a demo. Since this is data analysis with Python, we got to ask the question, why Python for data analytics? I mean, there's C++, there's Java, there's .NET from Microsoft. Why do people go to Python for it? So the number of reasons. 1, it's easy to learn with simple syntax. You don't have a very high typeset like you do in Java and other coding, so it allows you to kind of be a little lazy in your programming. That doesn't mean that it can't be set that way and that you don't have to be careful. It just means you can spin up a code much quicker in Python. The same amount of code to do something in Python a lot of times is 1, 2, or 3, or 4 lines, where when I did the same thing, say in Java, I found myself with 10, 12, 13, 20 lines, depending on what it was. It's very scalable and flexible. So there's our flexibility, because you can do a lot with it, and you can easily scale it up. You can go from something on your machine to using PySpark under the Spark environment and spread that across hundreds, if not thousands, of servers across terabytes of data or petabytes of data. So it's very scalable. There's a huge collection of libraries. This one's always interesting because Java has a huge collection of libraries. C has a huge collection of libraries. .NET does, and they're always in competition to get those libraries out. Scala for your Spark. All those have huge collections of libraries. This is always changing, but because Python's open source, you almost always have easy to access libraries that anybody can use. You don't have to go check your licensing and have special licensing like you do in some packages. Graphics and visualization, they have a really powerful package for that, so it makes it easy to create nice displays for people to read. And community support. Because Python is open source, it has a huge community that supports it. You can do a quick Google and probably find a solution for almost anything you're working on. Python libraries. Let's bring it together. We have data analytics and we have Python. So when we're talking data analytics, we're talking Python libraries for data analytics. And the big 5 players are NumPy, Pandas, Matplot library, SciPy, which is going to be in the background, so we're not going to talk too much about the scientific formulas in SciPy, and scikit. So NumPy supports n-dimensional arrays, provides numerical computing tools useful for linear algebra and Fourier transform. And you can think of this as just a grid of numbers. And you can even have a grid inside a grid, or data. It's not even numbers, because you can also put words and characters and just about anything into that array. But you can think of a grid, and then you can have a grid inside a grid, and you end up with a nice 3-dimensional array. If you want to talk 3-dimensional array, you can think of images. You have your 3 channels of color, 4 if you have an alpha, and then you have your XY coordinates for the image we're looking at. So you can go X, Y, and then what are the 3 channels to generate that color. And NumPy isn't restricted to 3 dimensions. You could imagine watching a movie. Well, now you have your movie clips, and they each have their X number of frames, and each of those frames have X number of XY coordinates for the pictures in each frame, and then you have your 3 dimensions for the colors. So NumPy is just a great way to work with n-dimensional arrays. Now closely with NumPy is pandas. Useful for handling missing data, perform mathematical operations, provides functions to manipulate data. Pandas is becoming huge because it is basically a data frame. And if you're working with big data and you're working in Spark or any of the other major packages out there, you realize that the data frame is very central to a lot of that. And you can look at it as a Excel spreadsheet. You have your columns, you have your rows or indexes, and you can do all kinds of different manipulations of the data within, including filling in missing data, which is a big thing when you're dealing with large pools or lakes of data where they might be collected differently from different locations. And Matplot library. We did kick over the SciPy, which is a lot of mathematical computations, which usually runs in the background of NumPy and Pandas. Although you do use them, they're useful for a lot of other things in there. But the Matplot library, that's the final part. That's what you want to show people. And this is your plotting library in Python. Several toolkits extend Matplot library functionality. There's like 100 different toolkits to extend Matplot library, which range from how to properly display star constellations from astronomy. There's a very specific one built just for that, all the way to some very generic ones. We'll actually add Seaborn in when we do the labs in a minute. Several toolkits extend Matplot library functionality, and it creates interactive visualization. So there's all kinds of cool things you can do as far as just displaying graphs, and there's even some that you can create interactive graphs. We won't do the interactive graphs, but you'll see, you'll get a pretty good grasp of some of the different things you can do in Matplot library. Let's jump over to the demo, which is my favorite. Roll up our sleeves, get our hands in on what we're doing. Now, there's a lot of options when we're dealing with Python. You can use PyCharm as a really popular one. And you'll see this all over the place. So it's one of the main ones that's out there, and there's a lot of other ones. I used to use NetBeans, which has kind of lost favor. Don't even have it installed on my new computer. But the most popular one right now for data science. Now, PyCharm's really popular for Python general development. For data science, we usually go to Jupyter Notebook or Anaconda. And we're going to jump into Anaconda because that's my favorite one to go to because it has a lot of external tools for us. We're not going to dig into those, but we will pop in there so you can see what it looks like. So with Anaconda, we have our Jupyter Lab, we have our Notebook. These are identical. Jupyter Lab is an upgrade to the Notebooks with multiple tabs. That's all it is. And we'll be using the Notebook. And you can see that PyCharm is so popular with Python that we even have it highlighted here in Anaconda as part of the setup. Jupyter Notebook can also be a standalone. So we're actually going to be running Jupyter Notebook. And then you have your different environments. We're going to be under main Py36. There's a root one. And I usually label it Py36. The reason is currently as of writing this, TensorFlow only works in 3.6 and not in 3.7 or 3.8 for doing neural networks. But you can actually have multiple environments, which is nice. They separate the kernels, so it helps protect your computer when you're doing development. And this is just a great way to do a display or a demo, especially if you're looking for that job. Pull up your laptop, open it up. Or if you're doing a meeting, get it broadcast up to the big screen so that the CEO can see what you're looking at. And when we launch the Notebook, it actually opens up a file browser in whatever web browser you have. This happens to be Chrome. And then you can just go under New. There's a lot of different options depending on what you have installed. Python 3. And this just creates an untitled version of this. And you can see here I'm actually in a Simplilearn folder for other work I've done for Simplilearn. And that's where I save all my stuff and I can browse through other folders, making it real easy to jump from one project to another. And under here, we'll go ahead and change the name of this, and we'll go ahead and rename it Data Analytics. Data Analytics. Just so I can remember what I was doing. which is probably about 50 of the folders in here, or files in here right now. So let's go ahead and jump in there and take a look at some of these different tools that we were looking at. And as we go through the demo, let's start with the NumPy, the least visually exciting. And I'm going to zoom in here so you can see what we're doing. And the first thing we want to do is import NumPy. And we'll import it as NP. That is the most common NumPy terminology. And let's go ahead and change the view so we also have the line numbers. I don't know why, we probably won't need them, but I like it for easy reference. And then we'll create a one-dimensional array. We'll just call this array1, and it equals np.array, and you put your array information in here. In this case, we'll spell it out. You can actually do like a range and other ways. There's lots of ways to generate these arrays. But we'll just do 1, 2, 3, so 3 integers. And if we print our array1, we can go ahead and run this. And you can see right here it prints 1, 2, 3. You can see why this is a really nice interface to show other people what you're doing with the Jupyter Notebook. So this is the basic. We've created an array. This is a one-dimensional array, and then the array is 1, 2, 3. One of the nice things about the Jupyter Notebook is whatever ran in this first setup is still running, is still in the kernel. So it still has the NumPy imported as NP, and it still has our variable ARR1 for array1 equal to NP array of 1, 2, 3. So when we go to the next cell, we can check the type of the array. We're just going to print. We say, hey, what is this setup in here? And we want type, and then we want, what is the type of array1? And let's go ahead and run that. And it says class NumPy ND array. So it's its own class. That's all we're doing is checking to see what that class is. And if you're going to look at the array class, probably the biggest thing you do, I don't know how many times I find myself doing this because I forget what I'm working on, and I forget I'm working with a 3-dimensional or 4-dimensional array. And I have to reformat somehow so it works with whatever other things I have. And so we do the array shape. The array shape is just 3 because it has 3 members and it's a one-dimensional array. That's all that is. And with the NumPy array, we can easily access, stick with the print statement. If you actually put a variable in Jupyter Notebook and it's the last one in the cell, it will be the same as a print statement. So if I do this, where array1 of 2, it's the same as doing print array of 2. Those are identical statements in our Jupyter Notebook. We'll go and stick with the print on this one. And it's 3. So there's our print space 2, and we have 0, 1, 2, 2 equals 3. We can easily change that. So we have array 1 of place 2 equals 5. And then if we print our array 1, you can see right down here when it comes out, it's 1, 2, and 5. And there I left the print statement off because it's the last variable in the list. It'll always print the variable if you just put it in like that. That's a Jupyter Notebook thing. Don't do that in PyCharm. I've forgotten before doing a demo. And we talked about multiple dimensions, so we'll do an array, 2-dimensional array. And this is again a NumPy array. And in the NumPy array, we need our first dimension. We'll do 1, 2, 3, and our second dimension 3, 4, 5. And you can see right here that when we hit the, we'll do this. We'll just do array 2. And we can run that, and there's our array 2, 1, 2, 3, 3, 4, 5. We can also do array 2 of 1. And then we can do, let's do 0. Doesn't really matter which one. Actually, let's do 2. There we go. And if I run this, it'll print out 5. Because here we are. This is 0. 0, 1, 2, 3 is on our 0 row. 3, 4, 5 is on our 1 row. I always start with 0. And then the 2, 0, 1, 2 goes to the 5. And then maybe we forgot what we were working with. So we'll go do array2.shape. And if we do array2 of shape, we'll go and run that. We'll see we have 2 rows and each row has 3 elements. Two-dimensional array, 2, 3. If you looked up here when we did it before, it just had 3 comma nothing. When you have a single entity, it always saves it as a tuple with a blank space. But you can see right here we have 2 comma 3. And if you remember from up here, we just did this array 2 of, let's go, what is it, 1 comma 2. We run that, we get the 5. You can also count backwards. This is kind of fun. And you'll see I just kind of switched something on you because you can also do 1 comma 2 to get to the same spot. Now 2 is the last one, 0, 1, 2. It's the last one in there. We can count backwards and do -1. And if we run this, we get the same answer. Whether we count it as, let's go back up here, whether we count this as 0, 1, 2, or we count backwards as -1, -2, -3. And you can see that if I change this -1 to a -2 and run that, I get 4, which is going backwards, -1, -2. So there's a lot of different ways to reference what we're working on inside the NumPy array. It's really a cool tool. It's got a lot of things you can do with it. And we talked about the fact that it can also hold things that are not values, and we'll call this array ask for strings equals np.array. Put our setup in there, our brackets, and let's go China, India, USA, Mexico. It doesn't matter, we can make whatever we want on here. And if we print that out, we run this, you can see that we get our NumPy array, China, India, USA, Mexico. It even gives us our D type of a U6. And a lot of times when you're messing with data, we'll call this array R for range, just to kind of keep it uniform. np.arange. So this is a command inside NumPy to create a range of numbers. And if you're testing data, maybe you want, maybe you have equal time increments that are spaced a certain point apart. But in this case, we're just going to do integers. And we're going to do a setup from 0 to 20, skipping every other one. And we'll print it out and see what that looks like. And you can see here we have 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Like you expected, it skips every one. And just a quick note, there's no 20 on here. Why? Well, this starts at 0 and counts up to 20. So if you're used to another language where it explicitly says less than or less than equal to 20, like for x equals 0, x plus plus, x is less than 20. That's what this is. It just assumes x is less than 20 on here. And if we want to create a very uniform set, 0, 2, 4, 6, what happens if I want to create numbers from 0 to 10, but I need 20 increments in there? We can do that with line space. So we can create an R, we'll call this L, equals, I don't think we'll actually use any of this again, so I don't know why I'm creating unique identifiers for it. But we'll do NP, lin space, and we're going to do 0 to 10, or 0 to 9. Remember, it goes up to 10. And then we want to, let's say we have 20 different increments in there. So we're creating we have a data set, and we know it's over a certain time period, and we need to divide that time period by 20. And it happens to just have 10 pieces in it. And here we go. You can see right here, we have 20, or it has 20 pieces in it, but it's over 10 years. And we got to divide it in the middle. And you can see it goes 0.52. Remember, yeah, there's our 10 on the end, so it goes up to 10. And then we can also do random. There's np.random. If you're doing neural networks, usually you start it by seeding it with random numbers. And we'll just do np.random, and we'll just call this array. We'll stop giving it unique numbers. We'll print that one out and run it. And you can see we have random numbers. They are 0 to 1. So you'll see that all of these numbers are under 1. And you can easily alter that by multiplying them out or something like that if you want to do like 0 to 100. You can also round them up if it's integer 0 to 100. There's all kinds of things you can do, but it generates a random float between 0 and 1. And you have a couple options. You could reshape that, or you can just generate them in whatever shape you want. And so we can see here, we did 3 and 4, and so you can see 3 rows by 4 variables. Same thing as doing a reshape of 12 variables to 3 and 4. And if you're going to do that, you might need an empty data set. I have had this come up many times where I need to start off with 0, and I don't know, because I'm going to be adding stuff in there, or it might be 0 and 1, where 1 is, if you're removing the background of an image, you might want the background is 0, and then you figure out where the image is, and you set all those boxes to 1, and you create a mask. So creating masks over images is really big, and doing that with a numpy array of 0, and we can also give it a space, and we'll just do this all in one shot this time, and we'll do the same thing like we did before, zeros, and in this case we'll do 2, 3. And so when we run this, forgot the asterisks around it. I knew I was forgetting something. There we go. So when we run this, you can see here we have our 10 zeros in a row, and maybe this is a mask for an image, and so it has 2 rows of 3 digits in it. So it's a very small image, little tiny pixel. And maybe you're looking to do something the opposite way. Instead of creating a mask of zeros and filling in with ones, maybe you want to create a mask of ones and fill them in with zeros. And we'll just do, just like we did before, we'll do 3, 4. And when we run this, you'll see it's all ones. And we could even do this even, we'll do it this way. Let's do 10 by 10 icon, and then you have your 3 colors. And you can, so it creates quite a large array there for doing pictures and stuff like that when you add that 3rd dimension in. If we take that off, it's a little bit easier to see. We'll do 10 again. And you can easily see how we have 10 rows of 10 ones. And you can also do something like create an array. And we'll do 0, 1, 2. And then in this array, we actually, we'll print it right out. We want a repeat. And so you can actually do a repeat of the array, and maybe you need this array, let's repeat it 3 times. So there's our repeat of an array, repeat 3 times. And if we run this, you'll see we have 0, 0, 0, 1, 1, 1, 2, 2, 2. And whenever I think of a repeat, I don't really think of repeating being the first digit 3 times, the second digit. I really always think of it as 0, 1, 2, 0, 1, 2, 0, 1, 2. It catches me every time. But the actual code for that one is going to be tile. And again, if we do arrange 3 and we run this, you can see how you can generate 0, 1, 2, 0, 1, 2, 0, 1, 2. And if you're dealing with an identity matrix, we can do that also if you're big on doing your matrices. And we'll just identity. I guess we'll go ahead and spell it out today. Matrix. And the command we're looking for is EYE. And we'll do 3. And then we'll just go ahead and print this out. There we go. There's our identity matrix. And it comes out by a 3 by 3 array, because there's our matrix. And then it puts the ones down the middle and for doing your different matrix math. And we can manipulate that a little bit too. We talk about matrices. We might not want ones across the middle, in which case we now have the diagonal. So we can do an np.diagonal. And we do a diagonal. Let's put in the diagonal 1, 2, 3, 4, 5. And when we run this, again, this generates a value. And by just putting that value in, there's the same as putting print around it, or putting array equals and then print array. And you can see it generates a diagonal 1, 2, 3, 4, 5, and there's your beginning of your matrix array for working with matrices. And we can actually go in reverse. Let's create an array equals, remember our random dot-random, and we'll do a 5 by 5 array. Oops, there we go. 5 by 5. And just so you can see what that looks like. Helps if I don't mistype the numbers, which in this case I just need to take out the brackets. And there you go. You have your 5 by 5 array set up in there. And we can now, because we're working with matrices, we might want to do this in reverse and extract the diagonals, which would be the 0.79, the 0.678, and so on. And we simply type in np.diagonal. We put our array in there. And this will, of course, print it out because it returns it as a variable. And you can see here's our diagonal going across from our matrix. And we did talk about shape earlier. If you remember, you can do print the shape out. You can also do the dimensions. So in dimensions, very similar to shape, it comes out and just has 2 dimensions. We can also look at the size. So if we do size on here, we can run that. And you can see it has a size of 25, 2 dimensions, and of course 5 by 5. And that was from the shape from earlier that we looked at. There's our 5 by 5 shape. And if you remember earlier we did random, well, you can also do random. I talked a little bit about manipulating 0 to 1 and how you can get different answers. You can also do straight for the integer part, and we'll do minus 10 to 10, 4. And so we're going to generate random integers between minus 10 to 10. We're going to generate 4 of those. And so when we run that, we have 7, minus 3, minus 6, minus 3. They're all between minus 10 and 10, and there's 4 of them. And now we jump into some of the functionality of arrays, which is really great, because this is where they come in. Here's your array, and you can add 10 to it. And if I run this, there takes my original array from up here with the integers and adds 10 to all of those values. So now we have, oh, this is the decimal, that's right. This is a random decimal I had stored in an array. But this takes a random decimal, the random numbers I had from 0 to 1 and adds 10 to them. And we can just as easily do minus 10. We could even do times 2. And we could do divide by 2. And it'll take that random number we generated and cut it in half. So now all these numbers are under 0.5. Another way you can change the numbers to what you need on there. And as you dig deeper into NumPy, we can also do exponential. So as an exponential function, which would generate some interesting numbers off of the random. So we're taking them to the power, I don't even remember what the original numbers in the array were, because we did the random numbers up there. Here's our original numbers, and if you build an exponential on there, this is where you get e to the x on this. And just like you can do e to the x, you can also do the log. So if you're doing logarithmic functions that reinforce learning, you might be doing some kind of log setup on there, and you can see the logarithmic of these different array numbers. And if you're working with log base 2, you can just change it in there, np log 2. You have to look it up, because this is not log 1, 2, 3, 4, 5. It is log and log 2. So just a quick note, that's not a variable going in. That is an actual command. There's a number of them in there, and you'll have to go look and see what the documentation is. But you can also do log 10. So here's log value 10. Some other really cool functions you can do with this is your sine. So we can take a sine value of all of our different values in there. And if you have sine, you of course have cosine. We can run that. So here's a cosine of those. And if you're doing activations in your NumPy array and you're doing a tangent activation, there's your tangent for that. And the tangent activation is actually from neural networks. That's one of the ways you can activate it, because it forms a nice curve between from whether you're generating 1 to -1 with some discrepancy in the middle. Just jumping a little bit in there into neural networks. And then we get into, let me just put the array back out there so that we can see it while we're doing this. As we're getting into this, you can also sum the values. So we have np sum, and you can do a summation of all the values in this array. And you'll see that if you added all these together, they'd equal 12.519, and so on. I don't know what the whole setup is in there. But you can see right here the summation of this. One of the things you can also do is by axes. So we could do axes equals 0. And if we run the summation of the axes equals 0, and you can think of that in NumPy as the rows. So that would be, or you can think of that in NumPy as being the columns. We're summing these columns going across. And you can also change this to 1, and now we're summing the rows. And so that is the summation of this row, and so forth going down. And maybe you don't need to know the summation. Maybe what you're looking for is the minimum. So here's our minimal. You're looking for, and this comes up a lot because you have like your errors. We want to find the minimal error inside of this array. And just like the other one, we can do axes equals 0. And you can see here 0.0645 is the smallest number in this first column is 0.0645 and so on. And if you have a minimum, well, you might also want to know the max. Maybe we're looking for the maximum profit. And here we go. You can see maximum 0.79 is the maximum on this first column. And just like we did before, you can change this to a 1 on axes. You can take the axes out of here and just find the max value for the whole array. And the max value in here was 0.8344, so on and so on. And since we're talking data analytics, we want to go ahead and look at the mean. Pretty much the same as the average. This is the mean across the whole thing. And just like we did before, we could also do axes equals 0. And then you'll see this is the mean of this axis and so on. And we have mean. We might want to know the median. And there's our median, our most common numbers. If we have median, we might want to know the standard deviation. Or if we have the average, a lot of times you do the means and the standard deviation. We can run that, and there's our standard deviations along the axes. We can also do it across the whole array. If we're going to do standard deviations, there's also variance, which is your VAR. And there's our variance across the different levels. And so if we looked at that, we looked at variance, we looked at standard deviation, the median, and the means. There's more, but those are the most common ones used with data analytics. And then going through your data and figuring out what you're going to present to the shareholders. And some other things we can do is we can actually take slices. You'll hear that terminology. And a slice might be, like we have a 5 by 5 array, but maybe we don't want the whole array. Maybe we want from 1 on, we don't want the 0 in there. So we got up to 4. And maybe on the second part, we just want 2 to row 3. And so this notation right here says 1 to the end. And if we run this, you can see how that generates a single row to the end, and then row 2 and 3. Now remember, it doesn't include 3. That's why we only get the 1 column. So if you wanted 2 and 3, you would need to go ahead and go 2 to 4. So it goes up to 4. We could also do this in reverse. Just like we learned earlier, we can go -1. Whoops. And when we go to -1, it's the same thing because we have 0, 1, 2, 3, 4. This is the same thing as 2 to 4. It goes 2 to the last one. Also very common with arrays is you're going to want to sort them. So we still have our array up here that we randomly generated, and we might want to sort it, and we'll go and throw an axis back in there. Axis equals 1. If we run this, you can see from the axes that it sorts it, the 0.2 being the lowest value to the highest value by the row. We can also change this, of course, to axis 0 if you're sorting it by columns. So maybe your values are based on columns. And then, of course, you can do the whole array, and we can sort that. Don't usually do that, but I guess sometimes that might come up. And so you can see right here we have a nice sorted array. Something else, let's just go ahead and reprint our array so we can look at it again. Starting to get too many boxes up there. Something else you can do with an array is we can take and transpose it. This comes up more than you would think. When you transpose it, you'll see that the rows in the column are transposed. So where 0.79, 0.57, 0.064 is a column, now we've switched it and we have 0.79, 0.42 as the index. You can see this really more dramatic if we take a slice, and we'll just do a slice of the first couple, and then we'll just do all the other, the full rows, and if we run this, you can see how it comes up a little bit different. And we'll just do the same slice up here so you can see how those two look next to each other. There we go, there's our slice, run. And so you can see the slice comes up and it has 1, 2, 3, 4, 5 columns. Now we have 1, 2, 3, 4, 5 rows and 3 columns versus 3 rows. And the original version, when they first started putting this together, was a function. So the original version was transpose, and this still works. You can still see it generates the same value as just a capital T. So many times we flip this data because we'll have an XY value or we'll have an image or something like that, and it's being read one way into the next process, and the next one needs it the opposite. So this actually happens a lot. You need to know how to transpose the data really quick. And we can go ahead, let's just take, here's our transpose. We'll just stick with the transpose on here. And instead of doing it this way, we might need to do something called flattening. Why would you flatten your data? If this is an array going into a neural network, you might want to send it in as one set of values instead of 2 rows. And you can see here is all the values as a single array. It just flattens it down into one array. So we covered our scientific means, transpose, median, some different variations on here. Some of the other things we want to do is what happens if we want to append to our array. So let's create a new array. I'm getting tired of looking at the same set of random numbers we generated earlier. So we'll go ahead and create a new array here, something a little simpler so it's easier to see what we're doing. And 4, 5, 6, 7, 8. That's good enough. We'll just do 4, 5, 6, 7, 8. And if we print this array, there it is, 4, 5, 6, 7, 8. And we might want to append something to the array. So we have our array, we need to extend it. You got to be very careful about appending things to your array, and there's a number of reasons for that. One is runtime. Because of the way the NumPy array is set up, a lot of times you build your data and then push it into the NumPy array instead of continually adding on to the array. And then it also it automatically generates a copy for protecting your data. So there's a lot of reasons to be careful about appending this way. But you can certainly do it. And we can just take our array, we're going to create a new array, array 1. And if we print array 1 and we append 8 to it, you'll see 4, 5, 6, 7, and then there's our 8 appended onto the end. And if you want to append something to an array, you'd probably also want to, whoops, array 1. Let's try that again. There we go. Now we have the 8 appended onto the end. So you can see 4, 5, 6, 7, 8, and then we appended another 8 on there. And if you're going to append something, you might want to go ahead and insert. Instead of appending, it might be you need to keep a certain order. And we can do the same thing. We can do our array, and we're going to append or insert at the beginning. And let's go ahead and insert 1, 2, 3. 1, 2, 3. And we go ahead and print our array 2. We run it, and you can see 1, 2, 3 is inserted at the beginning. Insert's a lot more powerful in that you can put it anywhere in the array. We can move it to the 1 spot, and there we go, 1, 2, 3. We can do a -1 just for fun, and you'll see it comes up 1, 2, 3, and we're counting backwards by 1. I imagine you can do a -0, and run this, and it turns out that -0 puts it back at the beginning, because that's how it registers as 0, it just takes a minus sign off. And just like we add numbers on, we might want to delete numbers. And so let's do an np.delete. Well, let's keep it a little bit, make it a little easy here to watch. We'll go ahead and create an array 3, and we'll do np delete. We were just working with array 2, and what we want to do is delete 0 space. So if you look at this, here's our array 2. Array 2 starts with 1. And when we delete the space on here and print that out, we deleted the 1 right out of there. And we can also do something like this, where we can do it as a slice. And we can do, let's do 1, 3. And if we run 1, 3, you'll see we've deleted the 1 space and the 3 space out, which deleted our 2 and 4. Now, keep in mind, when you're messing with adding lines and deleting lines, you have to be really careful, because there's a time element involved as far as where the data is coming from, and it's really easy to delete the wrong data and corrupt what you're working on, or to insert stuff where you don't want it. So there's always a warning when we talk about manipulating NumPy arrays. And just like anything else we're doing, we'll create an array C, which equals, we'll just do our NumPy array that we just created, our NumPy array 3, and we can do copy. So you can make a copy of it. Maybe you want to protect your original data, or maybe you're making a mask, and so you copy the array, and then the new array make all these alterations and change it from values to 0 to 1 to mask over the first one. And of course, if we do array C, since it equals a copy of array 3, it's the same thing, 1, 3, 5, 6, 7, 8. And now we're getting into combine and split arrays. I end up doing a lot of this, and I don't know how many times I end up fiddling with this and having a mess. But you do it a lot. You know, you combine your arrays, you split them, you might need one set of data for one thing, another set of data for the other. So let's go ahead and create 2 arrays, array 1, array 2. And I want you to note, and the terminology we're going to look for is concatenate. And what that means is we're going to take, we'll call this array cat. I like array cat. There we go. Our array cat, our concatenated array, we're taking array 1 and 2, and it's very important to really pay attention to your axes and your counts. I can't merge 2 arrays that have, like, if their axes are messed up and I'm merging on axis 0, it's going to give me an error and I'll have to reshape them. So you got to make sure that whatever you're concatenating together works. And what that means, as you can see here, we have 1, 2, 3, 4, 1, 2, 3, 4, and then 5, 6, 7, 8, 5, 6, 7, 8 along the 0 axis. These each are 4 values. So it's a 2 by 4 value. And if we go ahead and switch this to 1, you can see how that flips it a little bit. So now we have 1, 2, 3, 4, 5, 6, 7, 8. It's interesting that we chose that one. If I did something like this, where this is now, there we go, and we concatenate it, run this, and it gives me an answer okay, because I have 2 by 2, and I'm using axis 1. But if I switch this to axis 0, where now it's got 3 and 5, it gives me an error. So you got to be really careful on that to make sure that whatever axes you are putting together, that they match. So like I said, this one, oops, axis 1. Axis 1 has 2 entities, and since we're going on axis 1, or by row, you can see that it lets it merge it right onto the end there. And you could imagine this if this was a XY plot of value, or the X value going in and the predicted Y value coming out, and then you have another prediction and you want to combine them. This works really easy for that. And we'll go back, and let's just put this back to where we had it. Oops, I forgot how many changes I made. There we go. We'll just put it, whoops, I messed up in my concatenation order here. There we go. Okay, so you can see that we went through the different concatenation. Axes is really important when you're doing your concatenation values on here. We'll switch this back to 1 just because I like the looks of that better. There we go. 2 rows. Now, there are other commands in here. So we can do cat v equals np v stack. This is nothing more than your concatenation, but instead we don't have to put the axes in there because v stands for vertical. And so if we print out cat v and we run this, you can see we get the 1, 2, 3, 4, 1, 2, 3, 4, and that would be the same as making this axis 0 for vertical stack. And if you're going to have a vertical stack, you can also have an H stack. So if we change this from V stack to, oops, here we go, H stack, and we'll just change this from cat to cat, and I run this, it's the same as doing axis 0. The process is identical in the background. This is like a legacy setup, your V stack and your H stack. Most people just use concatenate and then put the axes in there. Is kind of data exploration, and that'll make a little bit more sense in just a moment. Sometimes they call them set operations. But let's say we have an array, 1, 2, 3, 4, 5, 6, 3, whatever it is. You can see we generate a nice little array here. And what I want to go ahead and do is find the unique values in that array. So maybe I'm generating what they call a one-hot encoder. And so these values then all become, I need to know how long my bit array is going to be. So each word, each word is represented by a number. And then I want to know just how many of those words are in there. If we're doing word count, very popular thing to do. And you can see here when we do unique, we have 1, 2, 3, 4, 5, 6. Those are our unique values. Some of the things we can do with the unique values is we can also, instead of doing just unique, we can do uniques, our unique values, and counts of each unique value. And this is very similar to what we just did up here where we're doing np unique, but we're going to add a little bit more into there. And it's just part of the arguments in this. And we want to do return counts equals true. So instead of just returning the unique values, we want to know how many of those unique values are in each one. And we'll go ahead and print our uniques and print our counts. When we run that, you can see here we have our unique value 1, 2, 3, 4, 5, 6, just like we had before. And then there's two of the first of 2 1s, 2 2s, 2 3s, 2 4s, 1 5, 2 6s, and so on. And you can go through and actually look at that if you want to count them. But a quick way to find out your distribution of different values. So you might want to know how often the word the is used versus the word and, if each word is represented as a unique number. And along the set variables, we might want to know, let me just put a note up here. We're going to start looking at intersection, and we might want to also know differentiation and neither. So when we're, neighbor, neither. So when we're looking at now is we want to know, hey, where do these two arrays intersect? And we have 1, 2, 3, 4, 5, 3, 4, 5, 6, 7. We might want to know what is common between the two arrays. And so when we do that, we have np intersect, and it's a 1D array, one-dimensional array. And then we need to go ahead and put array 1, array 2. And if we run this, we can see they intersect at 3, 4, 5. That's what they have common. And because we're going to go ahead and go through these and look at a couple different options, let's change this from intersect 1D. And we'll do the same thing. We'll go ahead and print this. So we might want to know the intersection where they have commonalities. Another unique word is union of 1D. So instead of intersect, we want to know all the values that are in both of them. So here's our union of 1D. When we run that, you can see we have 1, 2, 3, 4, 5, 6, 7. So it's all the different values in there. And one of the last words, we have 2 more to go. is we want to know what the set difference is. And so that's where you'll see that if you remember set, we talked about that being what they call these things. So the set difference of a 1D array, when we run that, you can see that 1 is only in one array and 2 is only in one array. And if we want to know what's in array 1 but not in array 2, we might want to know what is in array 1 but not 2 and what's in 2 but not 1. And this would be the set XOR 1D on here. So we have the 4 different options here where we can do an intersection. What do they both have in common? We can do a union. What are all the unique values in both arrays? We can see the difference, what's in array 1 but not array 2, so set diff 1D. And then set XOR, what is not in 1 but is in 2, and what is not in 2 but in 1. So we dug a lot in NumPy because we were talking, there's a lot of different little mathematical things going on in NumPy. A lot of this can also be done in pandas, although usually the heavy lifting is left for NumPy because that's what it's designed for. Let's go ahead and open up another Python 3 setup in here. And so we want to explore what happens when you want to display this. This is where it starts getting, in my opinion, a little fun because you're actually playing with it and you have something to show people. And we'll go ahead and rename this. We're going to call this pandas and pyplot. So pandas pyplot, just so I can remember for next time. And we want to go ahead and import the necessary libraries. We're going to import pandas as PD. Now remember, this is a data frame, so we're talking rows and columns, and you'll see how pandas work so nicely when you're actually showing data to people. And then we're going to have NumPy in the background. NumPy works with pandas, so a lot of times you just import them by default. Seaborn sits on top of the matplot library. So sometimes we use the Seaborn because it kind of extends. It's one of the 100 packages that extends the matplot library. Probably the most common used because it has a lot of built-in functionality. Almost by default, I usually just put Seaborn in there in case I need it. And of course we have matplot library as pyplot, as PLT. And note we have as PD, as NP, as SNS, as PLT. Those are pretty standard. So when you're doing your imports, I would probably keep those just so other people can read your code and it makes sense to them. That's pretty much a standard nowadays. And then we have the strange line here. It says ampersand matplot library inline. That is for Jupyter Notebook only. So if you're running this in a different package, it'll have a pop-up when it goes to display the matplot library. You can, with the most current version of Jupyter, usually leave that out and it will still display it right on the page as we go. And we'll see what that looks like. And then we're going to go ahead and just do the Seaborn, the sns.set, and we're going to set the color codes equals true. Let them just keep the default ones so we don't have to think about it too much. And we of course have to run this. The reason we run this is because these values are all set. If we don't run this and I access one of these afterward, it'll crash. The cool thing about Jupyter Notebooks is if you forgot to import one of these, you forgot to install it, because you do have to install this under your Anaconda setup or whatever setup you're in, you can flip over to Anaconda and run your install for these. And then just come back and run it. You don't have to close anything out. And we'll go ahead and paste this one in here real quick where we have car equals pd.read_csv. And then we have the actual path. This path, of course, will vary depending on what you are working with. So it's wherever you save the file at. And you can see here I have like my OneDrive documents, Simplilearn, Python, data analytics, using Python, / car CSV. It's quite a long file. When we open that up, what we get is we get a CSV file, and we have the make, the model, the year, the engine, fuel type, engine horsepower, cylinders, and so on. And this is just a comma separated file. So each row is like a row of data. Think of it as a spreadsheet. And then each one is a column of data on here. And as you can see right here, it has the make model. So it has columns for a header on here. Now, your pandas just does an excellent job of automatically pulling a lot of this in. So when you start seeing the pandas on here, you realize that you are already like halfway done with getting your data in. I just love pandas for that reason. NumPy also has it. You can load a CSV directly into NumPy, but we're working with pandas, and this is where it really gets cool, is I can come down here and I can print, you remember our print statement, we can actually get rid of it, and we're just going to do car head because it's going to print that out. The head is going to print the top values of that data file we just ran in. And so you can see right here, it does a nice printout. It's all nice and in line because we're in Jupyter Notebook. I can scroll back and forth and look at the different data. And just like we expected, we have our column, and it brought the header right in. One thing to note is the index. It automatically created an index 0, 1, 2, 3, 4, and so on. And we're just looking at the head. So we got 0, 1, 2, 3, 4. You can change this. You might want to just look at the top two. We can run that. There's our top two BMWs. Another thing we can do is instead of head, we can do tail. And look at the last three values that are in that data file. And you can see right here, it numbered them all the way up to 11,913. Oh my goodness, they put a lot of data in this file. I didn't even look to see how big the file was. So you can really easily get through and view the different data in here. When you're talking about big data, you almost never just print out car. In fact, let's see what happens when we do. If we run this and we just run the car, it's huge. In fact, it's so big that the pandas automatically truncates it and just does head plus tail, so you can see the two. So we really don't want to look at the whole thing. We'll go and go back to, let's stick with the head, displaying our data. There we go. So there's the head of our data. It gives us a quick look to see what's actually in there. I can zoom out if we want so you can actually get a better view. Although we'll keep it zoomed in so you can see the code I'm working on. And then from the data standpoint, we of course want to look at data types. What's going on with our data? What does it look like? Now this, you show when you're talking to your shareholders, they like to see these nice, easy to read charts. They look like a spreadsheet. So it's a nice way of displaying pieces of the chart. When we talk about the data types, now we're getting into the data science side of it. What are we working with? Well, we have make model, we have an integer 64 for the year. Engine fuel type is an object. If we go up here, you can see that most of them are it's a set manual, rear wheel drive. So they might be very limited number of types in there. And so forth. And it's either going to be a float 64, an integer, or an object is the way it's going to read it on here. And the next thing you're going to know is like your columns. And since it loaded the columns automatically, we have here the make, the model, the year, the engine, the size, all the way up to the MSRP. And just out of something you'll see come up a lot is whenever you're in pandas and you type in .values, it converts it from a pandas list to a NumPy array. And that's true of any of these. So then you end up in a NumPy array. So you'll see a little switch in there in the way that the data is actually stored. And that's true of any of these. In this case, we want car.columns. You have a total list of your car columns. And like any good data scientist, we want to start looking at analytical summary of the data set. What's going on with our data? So we can start trying to piecemeal it together. So we can do car, describe, and then what we'll do include equals all. So a nice panda command is to describe your data. If you're working with R, this should start looking familiar. And we come down here and you can see count. There's the make, the model, the year, how many of each one, how many unique values of each one, the top value of each one, what's most common, the frequency, the mean. Clearly on some of these it's an object, so it really can't tell you what the average is. It'd just be the top one's the average, I guess. The year, what's the average year on there? All this stuff comes down here. Your standard deviation, your minimum value, your maximum value, what's in the lower quarter, 50% mark, where's that line at? and what's in the upper 75%, the top 25% going into the max. Now, this next part is just cool. This is what we always wanted computers to be back like in the 90s, instead of 5,000 lines of code to do this. Maybe not 5,000. All right, I built my own plot library back in 95, and the amount of code for doing a simple plot was, I don't know, probably about 100 lines of code. This is being done in one line of code. We have our car, which is our pandas. We generated that. It's our data frame. And we have .hist for histogram. That is the power of Seaborn. Now, it's still going to generate a NumPy graph, but Seaborn sits on top, and then we can do the figure size. This is just so it fits nicely on the paper on here. And we do something simple like this, and you can see here where it comes up, and it does say matplot library and does subplots and everything. But we're looking at a histogram of all the different pieces in our database. And we have our engine cylinders. That's always a good one, because you can see like they have some that they had a null on there, so they came out as 0. Maybe one of them had a 2-cylinder engine way back when. 4 is a common, 6 a little less common, and then you see the 8-cylinder, 12-cylinder engines. Boy, that's got to be a speedster or something. But you can see right here, it just breaks it down. So now you have how many cars with how many, whatever it is, cylinders, horsepower, and so on. And it does a nice job displaying it. You can see if you're working with your, you're going into your demo, it's really nice just to be able to type that in and boom, there it is. They can see it all the way across. And we might want to zero in and use like a box plot. And this time we'll go ahead and call the Seaborn, SNS, box plot. And we're going to go ahead and do vehicle size versus engine horsepower XY plot. And the data comes from the car. So if we run this, we end up with a nice box plot. You see our mid-size, compact, and large. You can see the variation. There's our outlier showing up there on the compact. That must be a high-end sports car. Large car might have a couple engines, and again we have all these outliers and then your deviation on them. Very powerful and quick way to zero in on one small piece of data and display it for people who need to have it reduced to something they can see and look at and understand. And that's our Seaborn box plot, or our SNS.boxplot. And then if we're going to back out and we want a quick look at what they call pair plotting, we can run that, and you can see with the Seaborn it just does all the work for you. It takes it just a moment for it to pull the data in and compile it. And once it does, it creates a nice grid. And this grid, if you look at this one space here, which is, you might not be able to see the small number, it says engine horsepower. This is engine horsepower to the year it was built, and it's just flipped. So everything to the right of the middle diagonal is just the rotation of what's on the left. And as you expect, the engine horsepower gets bigger and bigger and bigger as time goes on. So the year it was built, the further up in the year, the more likely you are to have a heavy horsepower engine. And you can quickly look at trends with our pair plot coming up. And look how fast that was. It took it a couple, moment to process. But right away I get a nice view of all these different information, which I can look at visually and kind of see how things group and look. Now, if I was doing a meeting, I probably wouldn't show all the data. One of the things I've learned over the years is people, myself included, love to show all our work. We were taught in school, show all your work, prove what you know. The CEO doesn't want to see a huge grid of graphs, I guarantee it. So what we want to do is we want to go ahead and drop the stuff that might not be interested in. And I'm not really a car person. Our guy in the back is, obviously. So you have your engine fuel type. We're going to drop that. We're going to drop market category, vehicle style, popularity, number of doors, vehicle size. And we have the axes in here. If you remember from NumPy, we have to include that axes to make it clear what we're working on. That's also true with pandas. And then we'll look at just what it looks like from the head. And you can see that we dropped out those categories, and now we have the make, model, year, and so forth. And we took out the engine fuel type, market category, etc. And this should look familiar to you now. When you start working with pandas, I just love pandas for this reason. Look how easy it is. It just displays it as a nice spreadsheet for you. You can just look at it and view it very easily. It's also the same kind of view you're going to get if you're working in Spark or PySpark, which is Python for Spark across big data. This is the kind of thing that they come up with, and this is why pandas is so powerful. And we may look at this and decide we don't like these columns. And so you can go in here and we can actually rename the columns. Simple command, car equals car, rename. Columns equals engine horsepower equals horsepower. This is just your standard Python dictionary. So it just maps them out. And instead of having like the lengthy, if here we had engine horsepower, we just want horsepower. We don't need to know it's the engine horsepower. Engine cylinders, we don't need to know that it's for the engine, because there's only one thing we're describing if we're talking about cars, and that's cylinders. And we'll go ahead and just run this. And again, here's our car head, and you can see how that changed. We have model year and horsepower versus model year, engine horsepower, engine cylinders, and just cylinders. Again, we want to keep reducing this so it's more and more readable. The more readable you get it, the better. And of course, we can also adjust the size a little bit so that when it prints out, instead of splitting it on 2 lines, we get like a single line. We can do that also. That's just your control mouse up or plus sign you use in Chrome. That's a Chrome command. And if you remember from NumPy, we had shape. Well, pandas works the same way. We can look at the shape of the data. So we now have 11,914 rows and 10 columns. So you see some similarities because pandas is built on NumPy. And questions that come up just like you did in NumPy, we might want to know duplicate rows. And so we can do car. And look at this switch here. We're doing a selection. This is a pandas selection with the brackets. But we want to select it based on car.duplicated. So how many duplicates on there. So it's starting to look a little bit different as far as how we access some of the data on here. This can be a logical statement. And we get the number of duplicate rows. We have 989 rows by 10 columns again. And this is one of those troubleshooting things that we end up doing a lot, more than we really feel like we should. We might go ahead and do like a car count just to see how many rows we're dealing with. And then right after that, we might want to go ahead and say, hey, let's drop duplicates. So remember we did all the duplicates on there. So car equals car dot drop duplicates. And then we can print the head again. We'll just do car head here. And you can see the data on there looks the same as before. And just note that we did car equals car dot duplicates. There are commands in here where you can do, where it changes the actual value. And it works on some of them and not on others depending on what you're doing. But by default, it always returns a copy. So when we do this, we're reassigning it to car. And you can see it's the same header, but we want to go ahead and do count and see how the count changes. Let's go ahead and run this. And you can see here, instead of 11,914, we have 10,925. So we've removed about 100 cars that were duplicated, just slightly under 100 there. And then as we're prepping our data, we might want to know car is null. So it's going to count the values of null, and then we want to sum that up. And when we do that, we do the car is null function dot sum. We end up with HP, the horsepower is 69 have null values, and 30 have cylinders have null values. Now, if you don't put the sum at the end, it's just going to return a mask with the true false of is it null or is it not, by 0 and 1. So you're summing up the ones underneath each column. And this, of course, then you have to decide what you're going to do with the null values. There's a lot of different options. It might be that you need to put in the average or means. Maybe you want to put in the median value. There's a lot of different ways to fill it. Usually when you first start out with the data, a lot of them you just drop your null values. And you can see here car.drop NA, which is equal to all. And then we're going to go ahead and count it. And you can see that we've dropped almost another 100 values. So from 10,925 to 10,827, maybe 75 or so values. So we cleaned it. This is really a big part of cleaning data. You need to know how to get rid of your null values, or at least count them, and what to do with them. And of course, if we go back to counting our null values, we should now have null values. There we go. And you'll see there's 0 null values. I don't know how many times I've been running a model that doesn't take null values and it crashes, and I just sit there and look at it trying to get, why did that crash? It should have worked. It's because I forgot to remove the null values. So we've been jumping around a lot. We're going to go back to finding outliers. And let's go ahead and bring that back into our Seaborn. And if you remember, we did a box plot earlier. This time we're going to do a box plot just on the price. And you can see here our price value, and we have the deviation with the 2 thinner bars on each side of the main value. And then as we get up here, we have all these outliers. In fact, we have one way out here that's probably a really expensive high-end car is what we're looking at. If you were doing fraud analysis, you would be jumping on all over these outliers. Why are these deviation from the standard? What are these people doing? Again, this is probably, like I said, a really high-end expensive car out here. That's what we're looking at. And we can also look at the box plot for the horsepower. And we'll put that in down here and run that. And you can see again, here's our horsepower, and it just jumps, and there's these really odd, huge muscle cars out here that are outliers. And we're going to jump into making this a little bit more, as you start displaying your data or your information to your shareholders. We're going to look at plotting a histogram for the number of cars per brand. And the first thing we want to go ahead and do is we have with our car, go back over here, here we go. We have our make value counts, largest plot, and we want to do a kind equals bar, figure size 10.5. And right off the bat, we jump up here and we see Chevrolet. It's going against, what was it? It's figure ratio, the value counts, and we want the largest value. So here's our value counts and compared to what the different cars are. Chevrolet puts out a lot of different kinds of cars. I didn't realize that they made that many cars or different types. And then for readability, let's go ahead and add a title, number of cars by make, number of cars, and make. If you had looked at this the first time, you would have been like, well, what the heck am I looking at? Well, we're looking at the number of cars by make. And then you can see here, now we're talking about the type of cars and the different ones that are put out. Lotus, I guess, only had a few different kinds of cars over there. Very high-end cars. And then as doing data analytics and as a data scientist, one of the things I am most interested in is the relationship between the variables. So this is always a place to start. We want to know what's going on with our variables and how they connect with each other. So the first thing we're going to do is we're going to go ahead and set a figure size because we want to make sure it fits our graph. We'll just go ahead and set this one plot figure set to figure size 2010. If you never used the matplot library, which is sitting behind Seaborn, whatever is in the PLT, this is what's loaded. It's like a canvas you're painting on. So the second you load that PyPlot as PLT, anything you do to that is affecting everything on it. And then we want to go ahead, since we're using Seaborn, we'll go ahead and create a variable C for relationships or correspondence, and car.corr. That's a correlation in Seaborn on top of pandas. Again, one line and you get the whole correlation on there. And because we're working with Seaborn, let's put it into a nice heat map. If you're not familiar with heat maps, that means we're just using color as part of our setup. So we have a nice visual. And we can see here that the Seaborn connected to the pandas prints out a nice chart. We'll talk a little bit about the color here in a second. It prints out a nice chart. This is a chart I look at. As a data scientist, these are the numbers I want to look at. And we'll just highlight one of them. Here's cylinders versus horsepower. The closer to 1, the higher the correlation. So 0.788. Pretty high correlation between the number of cylinders and how heavy the horsepower is. I'm betting if you looked at the year versus horsepower, we can just look at that one. Here's year and horsepower. 0.314, not as so much, but if you combine them, you don't actually add them. But if you combine them, you'll start to see an increase in horsepower per year and cylinders. You could probably get a correlation there. And just like 0.78 is a positive correlation, you might notice if we look at cylinders, or let's look at horsepower and mileage. So if we go here to horsepower to mileage, you get a nice negative. We'll do cylinders, that's a bigger number. With cylinders to the miles per gallon, it's a minus 0.6. So it's a negative correlation. The closer to -1, the more the negative correlation is. And then the chart you would actually show people is a nice heat map. This is all our colors, and it's just those numbers put into a heat map. The darker the color, the higher the correlation. You can see straight down the middle, obviously the year correlates directly with the year, horsepower with horsepower, and so on. That's why it's a 1. The closer to the 1, the higher the correlation between the two pieces of data. Now, this is a good introduction. Pandas goes way beyond this. Most of the functionality in NumPy, since Pandas sits on it, is also in Pandas, and then it even has additional features in it. And we use Seaborn pretty extensively sitting on top over our pie plot. So keep in mind that our pie plot has a ton of other features in it that we didn't even touch on in here. We couldn't, even if you had a sole course in it, there's just so many things hidden in there depending on what your domain you're working on. But you can see here, here's our Seaborn and here's our Matplot library. That's all our graphics that we did. And then the Seaborn works really nicely with the pandas. We really like that. So that wraps up our demo part for today.
Let's understand a case study from Walmart and how it uses data analytics to grow its business and serve its customers better. Walmart is an American multinational retail company that has over 11,500 stores in 27 countries worldwide, and it has e-commerce websites in 10 different countries. It has more than 5,900 retail units operating outside the United States with 55 banners in 26 countries with more than 7 lakh associates serving more than 100 million customers every week. It has over 2.2 million employees around the world and 1.5 million employees in the United States alone. Walmart's e-commerce branch alone employs more than 3,000 technologists from Silicon Valley to India, England, and South America. More than 240 million customers shop at Walmart each week online and at its banner stores. Walmart.com sees up to 100 million unique visitors a month according to ComScore and is growing every year. Walmart collects over 2.5 petabytes of data from 1 million customers every hour. That's really huge. Now, to make sense of all this information, Walmart has created Data Cafe, a state-of-the-art analytics hub located within its Bentonville, Arkansas headquarters. Here, over 200 streams of internal and external data, including 40 petabytes of recent transactional data, can be modeled, manipulated, and visualized. Teams from any part of the business are invited to bring their problems to the analytics experts and then see a solution appear before their eyes on the Nerve Center's touchscreen smartboards. Walmart also constantly analyzes over 100 million keywords to know what people near each store are saying on social media to understand the customer behavior on what they like and dislike. Walmart uses modern tools and technologies to derive business insights and improve customer satisfaction. Some of these tools include Python, SAS, NoSQL databases such as Cassandra and Hadoop. Now, using all these technologies and data analysis techniques, Walmart can better manage its supply chain, optimize product assortment, personalize the shopping experience, give relevant product recommendations, and finally, optimize and analyze transportation lanes and routes for its fleet of trucks. With that, let's jump into our use case demo where we will predict the sales based on advertising expenditure using the linear regression model in R. The advertising expenditure has been made via different mediums such as radio, television, and newspaper. We will use the R programming software to implement the demo. So why R? Well, R is a free and open source software that can be downloaded from the RCRAN website. It is easy to learn and use. Our language is built specifically for performing statistical analysis, data manipulation, and data mining using packages such as plier, dplyr, tidyr, and lubritate. R supports data visualization with the help of packages such as ggplot, Google Viz, R Color Brewer, Leaflet, and ggmap. And finally, the R software can be used in a wide range of analytical modeling including classical statistical tests, linear and nonlinear modeling, data clustering, time series analysis, and more. Now, let's have a look at our data that we will be using for this demo. Here is our advertising CSV dataset, which has 4 columns. You can see there's TV ads expenditure. The next column is for radio ads. Then we have the newspaper ads. And the last column is our target column, that is the sales. So the data set has in total 200 rows. Now, to understand the data, let me give an example. So consider the second row. So suppose you spend around $230 on TV ads, then $37.8 on radio ads, and $69.2 in newspaper ads. You can expect to sell nearly 22 units of a particular product. Similarly, if you are spending $44.5 in TV advertising, $39.3 in radio ads, and $45 in newspaper ads, you can sell around 10 units of certain item. We will analyze this data using linear regression. So linear regression is a supervised learning algorithm, which means the data has labeled columns and is used to predict numeric continuous variables. So our sales column here is the target column and it has continuous numeric variables. Now let me go to the R Studio and start with the demo. So first, I'll create a new file, then I'll select R script. The next step is to install all the necessary packages that we need for this demo. If you already have the packages installed in your R Studio, you need not do it again. You can just call these packages using the library function and pass the package names. So first, I will install the dplyr package, which is used for data manipulation. I'll be using install.packages function and I'll give the package name. So I'll type install.packages. If you hit tab, it will autocomplete. Then under quotations, I'll write dplyr. I'm not going to run this because I already have it installed in my R Studio. The next step, I'll call this package using library function. I'll give the package name dplyr. I'll run this. Then I'll install the broom package. It takes the messy output of built-in functions in R such as linear model or LM, then t-test, and turns them into a tidy data frame. So I'll copy the above code. I'll just paste it again. I'll change it to broom. Here also I'll change it to broom. I'll run this. Okay. Then I'll be installing the CA tools package, which will help us build our linear regression model. I'll paste the same code and I'll take CA tools and I'll call that using the library function. I'll run this. Now sometimes people face issues with installing this particular package. If you also face this problem, do visit the R Studio community page. Now let me show it to you. So this is the R Studio community page and here they have the solution. You can just go through this 2 pages. Alright. After this, I will install the ggplot2 package, which is a very popular package in R for data visualization. I'm not running install.packages because I have already installed all these packages before. If you have not, so you have to run install.packages first and then call the library function. With that, let's now load the dataset. For this, I will use the read.csv function and provide the path location where my data is located, followed by the dataset name and the extension. I'll assign the loaded dataset to a variable. Let me now go ahead and show you where my dataset is located. So here is my advertising CSV dataset and this is the location. I'll copy this location. I'll move back to RStudio and let me comment this line, load the dataset. So I'll take a variable name ads and then using read.csv function I'll pass the path location where the dataset is present. Now one thing to note is we have to change all the backslash to forward slash, otherwise R won't accept it. And finally I'll give the dataset name, which is advertising.csv. Let me run it. Okay, we have successfully loaded our dataset. Now let us look at how our dataset looks like using the head function. So I'll give a comment, display the head of the dataset. I'll be using the head function and I'll pass ads. Run it. So you can see the head function has displayed the first 6 rows from the advertising dataset. Let me now check the dimensions of the dataset. So I'll use the dim function. It will give you the total rows and columns present in the dataset. Give a comment, check the dimensions. I'll use the dim function and I'll pass in the ads variable. You can see it has given the number of rows, which is 200, and the total columns, which is 4. Now if you want to get a summary of the dataset, you can use the summary function. So I'll directly type in summary and I'll give ads. Let me expand this. So actually summary function gives you information about a few statistics for each of the columns. So you can see the minimum value for each column, the maximum value for each column, the mean, the median, first quartile and the third quartile values. The first quartile or lower quartile is the value that cuts off the first 25% of the data when it is sorted in ascending order. The second quartile is the median, which has the value that cuts off the first 50%. And the third quartile or the upper quartile is the value that cuts off the first 75% of data. Moving ahead, let's do some data visualization now to visualize our data. Since our data has only numeric values, using scatter plots would be the best option. So we will visualize our sales against each of the independent variables. For that, I will use the plot function and give sales in my x-axis and the independent variable names in the y-axis. Let me now do that. So I'll give a comment, data visualization. First, I'll use the plot function and then in x-axis using the dollar symbol I'll give sales. Then in the y-axis I'll give my independent variable. You can see R is automatically giving you the suggestions. I'll select TV. Then I'll take type is equal to under quotes. I'll give P, which stands for points, and I'll take the color as red. So you can see under plots we have our scatter plot. If I zoom in, you can see the red dots are pretty much aligned in one direction, which means if you are increasing the expenditure on TV ads, the units sold are also increasing equally. So the more you spend on TV ads, the more sales you can expect. I'll close it. Now let's look at how sales vary based on radio advertising expenditure. I'll copy this. Paste it, and under y-axis I'll change it to radio, and I'll take the color now as, let's say, blue color. I'll run it. Now if I were to zoom in, now if you look at the blue dots, it is not that linear compared to our previous graph. You can see there are a few data points like this that show the sales were not good even after spending decent money on radio ads. But still you can expect a decent amount of sales if you are willing to spend on radio advertising. Close it. Let's now look at how sales will vary based on the newspaper advertising expenditure. I'll change the radio to newspaper column, and this time I'll take color as green. I'll run it. Let me zoom in. You can see the plots are very haphazardly present. The data is completely non-linear, and there seems to be a low correlation between the sales and newspaper advertising expenditure. Now if you want to look at these plots at a time, you can use the pairs function. So I'll type pairs and then pass in my variable name, which is ads. I'll run it. Let me zoom in. So this is our plot, and you can see this has all the visualizations. So you can see the TV sales. Now you can see the sales that were made with radio expenditure and with the newspaper expenditure as well. I'll close it. Moving ahead, let's check the correlation between the variables and see what insight we can get. We will use the core function or COR function and build a correlation matrix. First, let me go ahead and install the core plot package. So I'll give a comment, correlation analysis. For this, I will have to install the core plot package. I have already got it installed. Then I'll call this function using library. I'll run it. You can see core plot, the version has been uploaded. Now I'll tell you how you can grab only the numeric columns. Now our data only has numeric columns, but still let me tell you how you can do it. Since correlations are based on numeric columns only, this can be done using the sapply function. So for that we have already installed the dplyr library. I'll give a variable name as num.calls, which is numeric columns. Then I'll pass in the sapply function. I'll give the adds variable and I'll check if the variable is numeric or not. So I'll use is.numeric. Let me run it. And now let's display what's there in num.calls. You can see it says TV, it's true, which means TV has numeric values, even radio has numeric values. Similarly for newspaper and sales also. Then I'll use the correlation function, which is COR, to display the correlations between the variables. So I'll give my variable name as cor.data, and then I'll take the core function, pass in the adds variable, and I'll only filter out the numeric columns. So comma numeric columns means we need all the rows and the selected columns. Let me run it. And now to display, let me call cor.data again. So this is our correlation output. As you can see, the correlation values are all above 0, which means there is a positive correlation between the variables, and a change in one of the independent variables will have a positive impact on the sales numbers. TV ads have the maximum correlation with sales and the value is around 0.78. Then there is radio advertising, which has correlation of about 0.57 with sales, and newspaper ads have the lowest correlation compared to the other two, which is at 0.22. Now you can also build a correlation matrix using the correlation plot method. This will give you a visual representation of the correlation between the variables. So let's see how we can do that. I'll type core plot and I'll give core.data and I'll pass a method as color. If I zoom in, you can see this is our correlation matrix. On the right, you can see the scale. So -1 is for negative correlation. Then there's light red, 0, which is almost white color. Then there's light blue, and finally dark blue for the maximum positive correlation. The diagonals are dark blue, which represents the same variables as in rows and in columns. So it's dark blue. TV ads and radio ads have the next highest correlation, while newspaper ads have the lowest correlation with sales. With that, let's jump into the most important part of this analysis, which is building our regression model. First, we will look at a simple linear regression model where we will take one input variable, that is TV ads. I'll be using the lm function or the linear model function to build the model. So I'll give a comment, simple linear regression. I'll take a variable name as model underscore simple, and then using lm function I'll give my target variable, which is sales, and using tilde I'll give my independent variable, which is TV, and data as ads. I'll run it. Now that we have built our linear regression model, let's check the summary. Take summary function and I'll pass in model underscore simple. Let me run it. Now if I expand this, you can see our intercept estimate is around 7.03. So when the TV advertising budget is 0, we can expect sales to be around 7030 or 7030. Also remember, we are operating in units of thousand, and for every $1,000 increase in the TV advertising budget, we can expect the average increase in sales to be around 47 units. Now the same summary can be checked using the tidy function present in the broom package. So if I call tidy and I'll give the model name, which is model underscore simple, I'll run it. So there you go. This gives us a tidy representation of the summary figures. Now let's build a regression model with more than one input variable. So we'll build a multiple linear regression model. I'll take my variable name as model underscore multiple this time, and I'll use the same lm function. I'll pass in the sales, and using tilde I'll take all the column names. Stevie, then I'll use an addition operator, then I'll take in newspaper, followed by the radio column, and then I'll take my data as ads. Let's run it. I'll follow the same drill. Let me now call the summary function over this newly created model. So I'll write summary, and I'll select my model name as model underscore multiple. Let me run it. So the interpretation of our coefficients is the same as in simple linear regression model. First, we see that our coefficients for TV and radio advertising budget are statistically significant, since our p-value is less than 0.05, while the coefficient of newspaper is not, which is around 0.86. Thus, changes in the newspaper budget does not appear to have any relationship with changes in sales. However, for TV ads, our coefficient suggests that for every $1,000 increase in TV advertising budget, holding any other predictors constant, we can expect an increase in sales of 45 units on average. Similarly, the radio coefficient suggests that for every $1,000 increase in radio advertising, holding all the other predictors constant, we can expect an increase of 188 sales units on an average. Now you can also call the tidy function over this multiple linear regression model. So let me do that. I'll call tidy, and I'll pass in model underscore multiple. You can see it has given the output. Now you can also find the coefficients of the model using another method. It's called the coefficient matrix. Here is how you can do that. So take a variable name, and I'll use the summary function. I'll pass in model underscore multiple, and using the dollar symbol, I'll take the parameter as coefficient. Let me call C coefficient now. So these are the coefficients of different variables. Let me now show you another example of how you can train a linear regression model using the CA tools library. First, I'll take a seed value, a random seed value of say 101. Next, I will split the data into training and testing sets. I'll take 70% for training the data and 30% for testing the data. So I'll use a variable sample, then I'll call sample.split, take ads, and then I'll use another parameter called split ratio, and I'll take the split ratio as 0.7, which is 70%. I'll run it, and then I'll use another variable called train and take the subset of the sample, pass in my ads variable, and I'll select sample is equal to true. Similarly, I'll take another variable called test. I'll use my subset function and given the same parameters, but this time I'll take sample is equal to false, which means the test sample dataset won't have any values that are present in train dataset. I'll run it. Now we will use the same lm function to create our model. So I'll take model as my variable and assign it to lm function. So I'll assign the linear model to the model variable. I'll take sales as my target column, use the tilde followed by a dot, which means I'm taking all the variables in terms of the independent variables, and then I'll select my train dataset. With that, let's check the summary as well. So this is the summary of our newly created model. Now you can also check the residual collected from the trained model using the residuals function. Let me go ahead and assign a variable called res for residual, and I'll use the residuals function. Pass in my model. Then I'll convert the residuals into a data frame. So I'll use the as.dataframe function and pass in res. Now you can check the residuals. So these are the residual values. Now it's time to make our predictions using the test dataset. I'll use the predict function for this. Let me take another variable called sales.predictions, and I'll use the predict function, pass in my model followed by the test dataset. Now I'll run it. Then let me call sales.prediction to display the values. As you can see, these are my predicted sales values. Now let me combine these predicted sales values to our original sales for the test data. For that, I'll use the cbind function and pass the column names. I'll take another variable called results and use the cbind function. I'll take sales.predictions and I'll consider the sales column from the test data. Let me check the values now. So you have the predicted sales values and the original values of sales, but you can see the columns don't have any name assigned to them. So let me go ahead and assign the column names using the call names function and convert it into a data frame to make it look better. So I'll use the call names function and pass in my results variable. Then I'll take a vector and give the column names as spread for predicted values and let's say real for the original values. We run it. Now I'll convert this into a data frame. So I'll use as.data.frame and give my results variable. Now if I display results, you can see, go on top, you can see the columns have been assigned successfully. So on the left you have the predicted values and on the right you have the real values. So we have successfully built our linear regression model and predicted the sales values using linear regression in R. You can also go ahead and find the accuracy of this model to know how good your model is. We won't be covering that as part of this tutorial. I'll leave it for you and encourage you to do some research on how you can find the accuracy of a linear regression model. You will come across terms such as mean squared error, root mean squared error, and R squared value. If you are able to find the accuracy, please post the results in the comment section, or if you face any issues with it, please post your queries. We'll be happy to help you.
Let us quickly hop on to RStudio and start performing the hands-on exercise for data analysis. For this exercise, we will use a dataset named as demographics, which is in a .csv file type. Firstly, let us load the dataset to RStudio, and we will locate this in an variable named as demo. We also refer to this as a data frame. And now you will notice that a variable is created in an environment section, which is in the bottom right hand side of the RStudio window. And this particular variable comprises of 510 observations or records with 8 variables. Let us simply expand this particular data frame and have a quick check on the data structure and understand the data types. This particular data frame includes variables such as age, marital, income, the unit of income is dollar per day, education levels, the car price, car category with several levels, gender, and retired status. Now let us view the top 6 records of this particular data set. For this, let's simply type head of demo. And the result is now visible in the console section. If you're interested to view all the records, then simply type view of demo. And this new window will show you every single record that is being loaded to RStudio. You may also simply apply the filters and the filter section here on individual categorical variables. Now that we have loaded the dataset and also viewed individual records, let us focus on creating subsets of records by applying filters on individual variables or multiple variables. So firstly, let us apply filter on gender. We will only retrieve the records where gender is equal to female, and we will locate these records in a variable named as demo2. As you notice now in the environment section, the second variable is also created, that is demo. And this now is comprising of 250 observations, which means the records are filtered down to only gender female. Next, let us see how to apply a filter on income variable. Let us only retrieve the records where income is greater than 100. Let's view the result. As we see here, all the records include income greater than 100. Now let us modify this query and we will ensure that the retrieved records includes income greater than 100 and also specific variables are returned. Let's say we only want to have the first variable, third variable and the seventh variable returned as the result. Let's have a quick check. So we only have the first, third and the seventh variable returned. How about we only exclude the variable 6 to 8? For this we include a prefix of minus sign. And now let us see what is the result. We have the variables from first to the fifth variable. However, we don't have 6, 7 and 8th variable. I hope it's clear so far. Yes? Alright. Now let us see how can we apply condition by including both the variables, that is gender and income, and then we will filter the record and create a subset of data. Now let's view the result. Income is greater than 100 and the gender is only female. This is one way of creating subsets. However, now let us see how to use the subset command and create the subset. Let's create a subset of records by applying filter on marital status and age. We'll only retrieve records where marital status is equal to married and age is greater than 35. Let's now view the result. So here we have the age greater than 35 and marital status is married. Let's use the same code and this time we will retrieve selected variables. Let's say variables ranging from 1 to 3. Let's have a quick check. So there are 3 variables. Age is greater than 35 and marital status is married. Now let us see how to structure the data by sorting the data frame in ascending and in descending order. We will apply this order function on the variable income. Firstly, let us see how to order income variable in ascending order. Let's do a quick check. And here we have income in ascending order. Now let's see how to modify the same code and view the records with income in descending order. So we have now the income in descending order. How about include 2 variables and sort the variables accordingly? Firstly, we will sort the records by ordering income and age in ascending order. Let's quickly view the result. We have income in ascending and age as well in ascending. Let's now modify this code. This time we will order income in descending and age in ascending. Let us view the result. So the income is in descending and age is in ascending order. So hope this is clear on how to sort the data frame by ascending and descending order per variable or by using multiple variables. With this, we will focus on learning statistical analysis. How to perform statistical analysis on individual variable or multiple variable. Let's start by understanding the data distribution of variable income so that we identify what is the minimum value of income, what is the maximum, what is the range, what is median, what is the mean, and we will also focus on the quantile distribution, which is also analyzed in a box plot. What is the minimum value in the variable income? It's 9. And what is the maximum? So we have the maximum value. Now let us see what's the range. So the range shows you the result with minimum and the maximum value. How about the difference of maximum and the minimum? Now let us focus on other summaries of data distribution for this variable income. Let's identify what is the mean value of income. The mean is 78. Let's also understand what is the standard deviation. Alright, so the standard deviation is $112. Let us see what is the variance. The variance should be larger than the standard deviation. Now let's say what is the median absolute deviation. As you notice here, the median absolute deviation value is lower than standard deviation. Why do we make this comparison? From this, it is evident that median absolute deviation is robust to outliers and standard deviation is sensitive to outliers and also to the change in the mean value. Now let us understand the quantile distribution. This is the same analysis that is visualized in a box plot, ranging from 0% to 100%, identifying the individual data points. And we can also refer and compare this to the min, the max, and the median values. Let us quickly see what is the median value of income. As you notice here, the median is 45. As well, the 50th percent of quantile is 45, which means 0% is minimum and 100% is the maximum value. Now, if your question is what is 25% and 75%, this is again used for identifying the range of interquartile. The interquartile range is nothing but the difference of 75% minus the 25%. Let's quickly see what is the IQR of income. The IQR of income is 58. Let us do a quick check. 75% of quantile is 86 and 25% of quantile is 28. And the value is 58, which is equal to the IQR result. Now that we have focused on the statistical analysis of the individual variables data distribution, let us focus on the data visualization. In this, we will have a pictorial representation of analysis. to identify the outliers, to see what is the minimum and where do we see the data densely populated and how is it scattered, etc. We will begin with creating a histogram. Now histogram can be used for univariate analysis, which means in this scenario we will consider income variable and we will see how the count of income ranges gets distributed in a histogram. For this we will have to install a package called as ggplot2 and also call this library ggplot. Let us install the package. Now let us call the library. Alright, and we are ready now to begin with visualization. For this we will use the geometric object histogram on the demo data frame. Let me expand this window so that the code is visible, and also use an aesthetic mapping for variable income. This will be helpful for filling colors or filtrations, etc. And only include 30 bins with individual bin size width of 100, which means there will be 100 incomes in individual bins. Let's quickly look at the distribution of this histogram. As you notice, there are a couple of outliers. The counts of these income range are very limited. However, we see the densely populated income ranges with higher counts between 0 to $200 per day. This is also a way to identify and segment the customers based on their income ranges. Now let us see how to change the color of this histogram and also the border of the histogram. For this, we will include some additional options such as fill with blue color, and the border color is black. Now as you notice here, the executed code provides us the histogram with blue color bars and black color border lines. Now we will focus on creating a facet grid. Facet grid is also an aesthetic mapping object. We will see how to enable the multiple histograms across the marital status and the genders, so that we identify how the income is distributed for individual marital status as well the genders. Let's zoom this view and have a look at it. As you notice here, there are some interesting outliers here in the data distribution. Female unmarried drawing higher income, and male unmarried and married also drawing higher income as compared to the females. Whereas if you notice that the female unmarried is drawing much higher income than the male. This may also be very much related to the age. Now let us see how to create a stacked histogram. When I say a stacked histogram, I mean instead of filling the color, we will fill the gender, so that there is a stack within the histogram. as you notice here, I have made couple of changes. I have included fill equal to gender within the aesthetic mapping. Now let us look at this histogram. As you see here, the gender is filled in the histogram, hence we have stacked distribution of female and the male. Now let us focus on creating a bar chart with education versus income, where we can identify the education levels and the income ranges for these education levels. As you notice here, we are going to create a visualization where we have the aggregation in form of mean, and the geometric object used here is bar plot. Now let's zoom this view and understand which education level have higher average income. So as we see here, the blue color bar is the post undergraduate degree, which means this education level draws higher average income as compared to other education levels. Now let's create a histogram where we will see car price and the number of cars for individual category. Let's look at this visualization. This visualization provides us some interesting insight. Just by looking at the distribution of the car prices and the counts of the cars at the car category, economy, and even the luxury. Luxury car category or car price is pretty much distributed, whereas economy car category is dense, which means that we could also look back into the income and age variables and try to figure out further more insights, and then segment the customers for further targeting of these customers. Now what happens if we simply change this bin width to 30? As you observe here, changing the bin width or increasing the bin width will also reduce the number of bins. Now we only have 4 bins here, and the car category is filled. That is what we have enabled within the aesthetic mapping. And we see some more interesting insight. As you look at the standard and the luxury car category, the car prices are pretty much overlapping for the car category luxury and standard. This could be the starting car price of the luxury brands. Now let us create a clustered bar chart. Let's look at this visualization. In this visualization, as you observe, though we have enabled fill equal to gender in the aesthetic mapping, we do not have the view in stacked form, but we have the bars one besides the other. It is also because we have enabled a position called as position equal to dodge in the code. Now, what is the insight that we can draw from this visualization? As you see, postgraduate degree with female gender is drawing higher average income as compared to any other education level. Now let us see how to create a box plot for variable income across the genders. So the box plot can be enabled if there is a bivariate analysis to be performed on a continuous variable and a categorical variable, or multiple categorical variables with a continuous variable. Now let's look at this visualization. What does this say? We have data distribution of income for individual genders, that is for female and the male, and we also notice outliers here. Anything above this whisker is considered to be outliers. It might make more sense if we also include some coloring for these outliers, maybe also enable shape. So now we have colored the outliers and it's colored orange. Let's see if we can also enable the shapes. And now we have here the outlier color as well the shape enabled. Now let us see how to enable a violin plot. What is the utility of violin plot? With a box plot we understand the analysis and the distribution of the data points is to identify the outliers, to know what is the minimum value, what is the max, what is the median, and what are the outliers. But what is the purpose of a violin plot? Let us have a quick check. As you observe, there is some concentration of data points in the bottom of every car category. However, the concentration is higher for standard car category as compared to economy and the luxury. Now this is an interesting insight that you wouldn't have come across in box plot. The box plot is a very good representation for identifying outliers. However, violin plot will help you focus on the nuances which is not captured by the box plot. We can also simply combine the box plot and the violin plot together. Simply include this geo object. Let's zoom this. Now you have a representation of box plot and the violin plot, both combined in a single visualization. Interestingly, you notice the outliers as well the concentration in the bottom of this violin plot. So this could be some interesting insights that you draw and focus on these data points and understand what exactly is happening there. Now let's focus on the density plot, that is density estimate of the histograms rather than just viewing the frequencies. Now we see the frequency in the y-axis across the income distributions. How about enabling the probability as true, so that we enable the density instead of the frequency? So now we have the density in the y-axis, and in the x-axis we still have the income distribution. This is the way of also adding a line plot, which is a density plot on the histogram. Now as you observe here, the density plot is not in the same level as the bar. So let us adjust this line. For this we will include adjust, let's say equal to 3, and now let us see how the visualization appears. Now the density plot is on the same level as the bar. Now let us see how to create a cross table for car category and gender. For this, let us call the library DESCR. Now let us create the visualization, enabling cross table for car category and gender. Let's look at the result in console. As you see here, now we see the counts of the gender for individual car category. The values over here represents that there are 67 females falling within the car category economy and 80 males within the car category economy. And for luxury, we see that the count of female is higher than the male. As well, the proportions. Now, how do you understand what proportions are presented here? We may simply turn off some of the proportions like the t-test, the chi-square, etc. Let us see how to enable that. Now let's look at the result. This looks better. Now that we have the counts, the female counts and the male counts across individual car category, we also see the percentages rather than just looking at the absolute value. So there are 45.6% of female within the car category economy and 54.4% of male within the car category economy. Similarly across rest of the car categories. This kind of cross table or a contingency table is also helpful when you want to analyze the different categorical variables and identify the counts or the proportions. Now let us see how to use a scatter plot of age versus income. Scatter plot is a visualization used for bivariate analysis. When you want to perform some analysis between two continuous variables at a data point level, rather than performing the analysis at an aggregated level, such as sum or mean. And now we have a scatter plot of age versus the income, age in the x-axis and income in the y-axis. Though we do not see any kind of a positive correlation or a negative correlation, but we still see some interesting insights over here. Some of the data points are pretty much scattered and much away from densely populated data points. I hope the learning has been informative and interesting so far. We have covered the concepts of data analytics, as well we have performed some hands-on, doing some statistical analysis and also creating interesting visualization.
Now we have Shruti, who will tell us the top 10 data analysis tools and help us understand data analytics jobs, resume, salary, career skills, roles and responsibilities. Finally, she will help you learn the difference between a data scientist and a data analyst. Over to Shruti now.
To achieve the goals of data analysis, we use a number of data analysis tools. Companies rely on these tools to gather and transform their data into meaningful insights. So which tool should you choose to analyze your data? Which tool should you learn if you want to make a career in this field? We will answer that in this session. After extensive research, we have come up with these top 10 data analysis tools. Here, we will look at the features of each of these tools and the companies using them. So let's start off. At number 10, we have Microsoft Excel. All of us would have used Microsoft Excel at some point, right? It is easy to use and one of the best tools for data analysis. Developed by Microsoft, Excel is basically a spreadsheet program. Using Excel, you can create grids of numbers, text, and formulae. It is one of the widely used tools, be it in a small or large setup. The interface of Microsoft Excel looks like this. Let's now move on to the features of Excel. Firstly, Excel works with almost every other piece of software in Office. We can easily add Excel spreadsheets to Word documents and PowerPoint presentations to create more visually appealing reports or presentations. The Windows version of Excel supports programming through Microsoft's Visual Basic for Applications (VBA). Programming with VBA allows spreadsheet manipulation that is difficult with standard spreadsheet techniques. In addition to this, the user can automate tasks such as formatting or data organization in VBA. One of the biggest benefits of Excel is its ability to organize large amounts of data into orderly, logical spreadsheets and charts. By doing so, it's a lot easier to analyze data, especially while creating graphs and other visual data representations. The visualization can be generated from a specified group of cells. Those were few of the features of Microsoft Excel. Let's now have a look at the companies using it. Most of the organizations today use Excel. Few of them that use it for analysis are the UK-based company Ernst & Young. Then we have Urban Pro, Wipro, and Amazon. Moving on to our next data analysis tool, at number 9, we have RapidMiner. A data science software platform, RapidMiner provides an integrated environment for data preparation, analysis, machine learning, and deep learning. It is used in almost every business and commercial sector. RapidMiner also supports all the steps of the machine learning process. Seen on your screens is the interface of RapidMiner. Moving on to the features of RapidMiner. Firstly, it offers the ability to drag and drop. It is very convenient to just drag drop some columns as you are exploring a data set and working on some analysis. RapidMiner allows the usage of any data, and it also gives an opportunity to create models which are used as a basis for decision making and formulation of strategies. It has data exploration features such as graphs, descriptive statistics, and visualization, which allows users to get valuable insights. It also has more than 1,500 operators for every data transformation and analysis task. Let's now have a look at the companies using RapidMiner. We have the Caribbean airline Leeward Islands Air Transport. Next, we have the United Health Group, the American online payment company PayPal, and the Austrian telecom company Mobilcom. So that was all about RapidMiner. Now let's see which tool we have at number 8. We have Talent at number 8. Talent is an open source software platform which offers data integration and management. It specializes in big data integration. Talent is available both in open source and premium versions. It is one of the best tools for cloud computing and big data integration. The interface of Talent is as seen on your screens. Moving on to the features of Talent. Firstly, automation is one of the great boons Talent offers. It even maintains the tasks for the users. This helps with quick deployment and development. It also offers open source tools. Talent lets you download these tools for free. The development costs reduce significantly as the processes gradually speed up. Talent provides a unified platform. It allows you to integrate with many databases, SaaS, and other technologies. With the help of the data integration platform, you can build flat files, relational databases, and cloud apps 10 times faster. Those were the features of Talent. The companies using Talent are Air France, L'Oreal, Capgemini, and the American multinational pizza restaurant chain Domino's. Next on the list at 7 we have NIME. Constance Information Miner on NIME is a free and open source data analytics, reporting and integration platform. It can integrate various components for machine learning and data mining through its modular data pipelining concept. NIME has been used in pharmaceutical research and other areas like CRM customer data analysis, business intelligence, text mining, and financial data analysis. Here is how the interface of NIME application looks like. Now coming to the NIME features. NIME provides an interactive graphical user interface to create visual workflows using the drag and drop feature. Use of JDBC allows assembly of nodes blending different data sources, including pre-processing such as ETL, that is extraction, transformation, loading, for modeling, data analysis, and visualization with minimal programming. It supports multi-threaded in-memory data processing. NIME allows users to visually create data flows, selectively execute some or all analysis steps, and later inspect the results, models, and interactive views. NIME Server automates workflow execution and supports team-based collaboration. NIME integrates various other open-source projects such as machine learning algorithms from Becca, H2O, Keras, Spark, and our project. NIME allows analysis of 300 million custom addresses, 20 million cell images, and 10 million molecular structures. Some of the companies hiring for NIME are United Health Group, ASML, Fractal Analytics, Atos, and Lego Group. Let's now move on to the next tool. We have SAS at number 6. SAS facilitates analysis, reporting, and predictive modeling with the help of powerful visualizations and dashboards. In SAS, data is extracted and categorized, which helps in identifying and analyzing data patterns. As you can see on your screens, this is how the interface looks like. Moving on to the features of SAS. Using SAS, better analysis of data is achieved by using automatic code generation and SAS SQL. SAS allows you to access through Microsoft Office by letting you create reports using it and by distributing them through it. SAS helps with an easy understanding of complex data and allows you to create interactive dashboards and reports. Let's now have a look at the companies using SAS. We have companies like Genpact, IQVIA, Accenture, and IBM to name a few. That was all about SAS. So for all those who joined in late, let me just quickly repeat our list. At number 10, we have Microsoft Excel. Then at number 9, we have RapidMiner. At number 8, we have Talent. At number 7, we have NIME. And at number 6, we have SAS. So far, do you all agree with this list? Let us know in the comment section below. Let's now move on to the next 5 tools in our list. So at number 5, we have both R and Python. Yes, we have 2 of them in the 5th position. R is a programming language which is used for analysis as well. It has traditionally been used in academics and research. Python is a high-level programming language which has a Python data analysis library. It is used for everything starting from importing data from Excel spreadsheets to processing them for analysis. This is the interface of R. Next up is the interface of the Python Jupyter Notebook. Let's now move on to the features of both R and Python. When it comes to the availability of R and Python, it is very easy. Both R and Python are completely free, hence it can be used without any license. R used to compute everything in memory and hence the computations were limited, but now it has changed. Both R and Python have options for parallel computations and good data handling capabilities. As mentioned earlier, as both R and Python are open in nature, all the latest features are available without any delay. Moving on to the companies using R, we have Uber, Google, Facebook, to name a few. Python is used by many companies. Again, to name a few, we have Amazon, Google, and the American photo and video sharing social networking service, Instagram. That was all about R and Python. At number 4, we have Apache Spark. Apache Spark is an open source engine developed specifically for handling large-scale data processing and analytics. Spark offers the ability to access data in a variety of sources, including Hadoop Distributed File System HDFS, OpenStack Swift, Amazon S3, and Cassandra. It allows you to store and process data in real time across various clusters of computers using simple programming constructs. Apache Spark is designed to accelerate analytics on Hadoop while providing a complete suite of complementary tools that include a fully featured machine learning library, a graph processing engine, and stream processing. So this is how the interface of Apache Spark looks like. Now let's look at the important features of Apache Spark. Spark stores data in the RAM, hence it can access the data quickly and accelerate the speed of analytics. Spark helps to run an application in a Hadoop cluster up to 100 times faster in memory and 10 times faster when running on disk. It supports multiple languages and allows the developers to write applications in Java, Scala, R, or Python. Spark comes up with 80 high-level operators for interactive querying. Spark code for batch processing, join stream against historical data, or run ad hoc queries on stream state. Analytics can be performed better as Spark has a rich set of SQL queries, machine learning algorithms, complex analytics, etc. Apache Spark provides fault tolerance through Spark RDD. Spark resilient distributed data sets are designed to handle the failure of any worker node in the cluster. Thus, it ensures that the loss of data reduces to zero. Conviva, Netflix, IQVIA, Lockheed Martin, and eBay are some of the companies that use Apache Spark on a daily basis. At number 3, we have another important growing data analysis tool, that is QlikView. QlikView software is a product of Qlik for business intelligence and data visualization. QlikView is a business discovery platform that provides self-service BI for all business users and organizations. With QlikView, you can analyze data and use your data discoveries to support decision-making. QlikView is a leading business intelligence and analytics platform in Gartner Magic Quadrant. On the screen, you can see how the interface of QlikView looks like. Now talking about its features. QlikView provides interactive guided analytics with in-memory storage technology. During the process of data discovery and interpretation of collected data, the QlikView software helps the user by suggesting possible interpretations. QlikView uses a new patent in-memory architecture for data storage. All the data from the different sources is loaded in the RAM of the system and it is ready to be retrieved from there. It has the capability of efficient social and mobile data discovery. Social data discovery offers to share individual data insights within groups or out of it. A user can add annotations as an addition to someone else's insights on a particular data report. QlikView supports mobile data discovery within an HTML5-enabled touch feature which lets the user search the data and conduct data discovery interactively and explore other server-based applications. QlikView performs OLAP and ETL features to perform analytical operations, extract data from multiple sources, transform it for usage, and load it to a data warehouse. The companies that can help you start your career in QlikView are Mercedes-Benz, Capgemini, Citibank, Cognizant, and Accenture, to name a few. At number 2, we have Power BI. Power BI is a business analytics solution that lets you visualize your data and share insights across your organization or embed them in your app or website. It can connect to hundreds of data sources and bring your data to life with live dashboards and reports. Power BI is the collective name for a combination of cloud-based apps and services that help organizations collate, manage, and analyze data from a variety of sources through a user-friendly interface. Power BI is built on the foundation of Microsoft Excel and has several components such as Windows desktop application called Power BI Desktop and online software as a service called Power BI Service, mobile Power BI apps available on Windows phones and tablets, as well as for iOS and Android devices. Here is how the Power BI interface looks like. As you can see, there is a visually interactive sales report with different charts and graphs. Moving on to the features of Power BI. It has an easy drag and drop functionality with features that make data visually appealing. You can create reports without having the knowledge of any programming language. Power BI helps users see not only what's happened in the past and what's happening in the present, but also what might happen in the future. It offers a wide range of detailed and attractive visualizations to create reports and dashboards. You can select several charts and graphs from the visualization pane. Power BI has machine learning capabilities with which it can spot patterns in data and use those patterns to make informed predictions and run what-if scenarios. Power BI supports multiple data sources such as Excel, Text CSV, Oracle, SQL Server PDF, and XML files. The platform integrates with other popular business management tools like SharePoint, Office 365, and Dynamics 365, as well as other non-Microsoft products like Spark, Hadoop, Google Analytics, SAP, Salesforce, and MailChimp. Some of the companies using Power BI are Adobe, AXA, Carlsberg, Capgemini, and Nestle. Moving on to the next tool. So any guesses as to what we have at number 1? You can comment in the chat section below. Finally, on the top of the pyramid, we have Tableau. Gartner's Magic Quadrant of 2020 classified Tableau as a leader in business intelligence and data analysis. Tableau Interactive Data Visualization Software Company was founded in Jan 2003 in Mountain View, California. Tableau is a data visualization software that is used for data science and business intelligence. It can create a wide range of different visualization to interactively present the data and showcase insights. The important products of Tableau are Tableau Desktop, Tableau Public, Tableau Server, Tableau Online, and Tableau Reader. This is how the interface of Tableau Desktop looks like. Now, coming to the features of Tableau. Data analysis is very fast with Tableau, and the visualizations created are in the form of dashboards and worksheets. Tableau delivers interactive dashboards that support insights on the fly. It can translate queries to visualizations and import all ranges and sizes of data. Writing simple SQL queries can help join multiple datasets and then build reports out of it. You can create transparent filters, parameters, and highlighters. Tableau allows you to ask questions, spot trends, and identify opportunities. With the help of Tableau Online, you can connect with cloud databases, Amazon Redshift, and Google BigQuery. The companies using Tableau are Deloitte, Adobe, Cisco, LinkedIn, and the American e-commerce giant Amazon, to name a few. And there you go, those are the top 10 data analysis tools. Hello everyone, we have an interesting topic for today, and that is data analytics jobs, career, and salary. I will run you through the top 6 data analytics job roles. So before I dive deep into the various job roles, let's quickly understand how important a career in data analytics is and what the future holds for professionals in this domain. Let's take a look at the growth of data. So back in the early 2000s, there was relatively less data generated, but with the rapid rise in technologies and with the increase in the number of various social media platforms and multinational companies across the globe, the generation of data has increased by leaps and bounds. Did you know that according to the IDC, the total volume of data is expected to reach 175 zettabytes in 2025? Now that's a lot of data. Let's take a look at how organizations leverage all of this data. As you know, there are zillions of companies across the world. These companies generate loads of data on a daily basis. When I say data here, it simply refers to business information, customer data, customer feedback, product innovations, sales reports, and profit loss reports, to name a few. Companies utilize all of this data in a wise way. They use all of this information to make crucial decisions that can either hamper or boost their businesses. You might have heard of the term data is the new oil. Well, it definitely is, but only if organizations analyze all the available data very well, then this oil is definitely valuable. And for that, we have data analytics. Organizations take the help of data analytics to convert the available raw data into meaningful insights. So what is data analytics? Technically, you can say it is a process wherein data is collected from various sources, then cleaned, which involves removing irrelevant information, and then finally transformed into some meaningful information that can be interpreted by humans. Various technologies, tools, and frameworks are used in the analysis process. As you might have heard of the term data never sleeps. Well, it surely doesn't. Every millisecond, some or the other data is generated, and this is a constant process. This process is only going to increase in the near future with the advent of newer technologies. The data analytics domain holds paramount importance in every sector. Companies want to leverage on all the generated big data and boost their businesses. They need professionals who can play with data and convert them into crucial insights. Organizations are constantly on the lookout for such candidates, and this opportunity will only increase as data is only going to grow every second. So if you want to start your career in this field, or if you want to switch your job role into a role in the data analytics domain, then we have a set of job profiles that you can look at. We will look into 6 job roles in the data analytics field and learn what each job role is all about, the responsibilities of a professional working in that particular role, the skills required to get that particular job, the average annual salary of a professional working in that role, and finally the company is hiring for that role. So let's start off. First, we have the job role of a data analyst. A data analyst is a person who collects, processes, and performs statistical analysis of large data sets. Every business generates and collects data, be it marketing research, sales figures, logistics, or transportation costs. A data analyst will take this data and figure out a variety of measures, such as how to price new materials, how to reduce transportation costs, or how to deal with issues that cost the company money. They deal with data handling, data modeling, and reporting. Now, talking about their responsibilities, data analysts recognize and understand the organization's goal. They collaborate with different team members such as programmers, business analysts, engineers, and data scientists to identify opportunities for solving business problems. Data analysts write complex SQL queries, scripts, and store procedures to gather and extract information from multiple databases. They filter and clean data using different modern tools and techniques and make it ready for analysis. They also perform data mining from primary and secondary data sources. Data analysts identify, analyze, and interpret trends in complex data sets. This is done using statistical tools such as R and SAS. Another key responsibility of a data analyst is to create summary reports and build various data visualizations for decision making and presenting it to the stakeholders. Next, let us discuss the important skills that you need to know to become a data analyst. Firstly, you should have a bachelor's degree in computer science or information technology. A master's degree in computer applications or statistics is also preferable. You must have a good understanding of programming languages like R, Python, JavaScript, and also understand SQL. In addition to that, it is beneficial if you have hands-on experience with statistical and data analytics tools such as SAS Miner, Microsoft Excel, and SSAS. Basic understanding of machine learning and its algorithms would be an advantage. Acquaint yourself with descriptive, predictive, prescriptive, and inferential statistics. Most importantly, you need to have a good working knowledge of various data visualization software along with presentation skills. This will help you pitch in your ideas and viewpoints to the clients and stakeholders better. Now talking about their salaries, a data analyst earns nearly 5,23,000 rupees per annum in India, while in the United States they earn around $62,453 per annum. Let's now look at a few of the companies hiring data analysts. So as you can see, we have the American e-commerce giant Amazon, then we have Microsoft, the American online payment company PayPal, then we have Walmart, Bloomberg, and Capital One. So that was all about data analyst. The next job role is of a business analyst. Business analysts help guide businesses in improving products, services, and software through data-driven solutions. They are responsible for bridging the gap between IT and business using data analytics to evaluate processes, determine requirements, and deliver data-driven recommendations and reports to executives and stakeholders. Business analysts are responsible for creating new models that support business decisions and come up with initiatives and strategies to optimize costs. Now let us look at the various responsibilities of a business analyst. Business analysts have a good understanding of the requirements for business. Their vital role is to work in accordance with relevant project stakeholders to understand their requirements and translate them into details which the developers can understand. They frequently interact with developers and come up with a plan to design the layout of a software application. They also run meetings with stakeholders and other authorities. They engage with business leaders and users to understand how data-driven changes to products, services, software, and hardware can improve efficiencies and add value. They ensure that the project is running smoothly as per the requirements and the design planned through user acceptance and validation testing. They make sure all the features are being incorporated into the application. BAs rely on different software to write documentation and design visualization to explain all the findings. It is extremely critical for any BA to effectively document the findings where each requirement of the client is mentioned in detail. Now let us look at the skills required for a BA. A bachelor's degree in the field of science, engineering, or statistics or any related domain will suffice. Knowledge of programming languages such as Python and Java is beneficial. You should be really good at writing complex SQL queries, and you should also have knowledge of various business process models. Along with knowledge of programming languages, ideas about statistical analysis and predictive modeling is necessary. Decision-making, strong analytical and problem-solving skills are necessary to solve software and business issues. You also need to have excellent presentation and communication skills, both oral and written. Moving on to their salary, a business analyst is expected to earn around 7 lakh rupees per annum in India. In the US, they earn nearly $68,346 per annum. IQVIA, Dell, Philips, Honeywell, the famous American messaging platform WhatsApp, the UK-based company Ernst & Young are few of the companies hiring for business analysts. Up next, we have the job role of a database administrator. A database administrator is a specialized computer systems administrator who maintains a successful database environment by directing or performing all related activities to keep the organization's data secure. They are responsible for storing, organizing, and retrieving data from several databases and data warehouses. Their top responsibility is to maintain data integrity. This means that database administrator will ensure that the data is secure from unauthorized access. Moving on to their responsibilities. A database administrator develops, designs, and maintains a database to ensure that the data in it is properly stored, organized, and managed well. They maintain data integrity by avoiding unauthorized access, and they keep databases up to date. They run tests and modify the existing databases to ensure that they operate reliably. They also inform end users of changes in databases and train them to utilize systems. They need to cooperate with programmers, data analysts, and the IT staffs to ensure smooth running and maintenance of databases. Database administrators are responsible for taking system backups in case of power outages and other disasters. So they should have an efficient disaster recovery plan. Now let's have a look at their skills. To become a database administrator, you should have a bachelor's degree in computer science or information technology. Knowledge of programming languages such as Python, Java, and Scala is important. You need to carry at least 3 to 5 years of experience in data management. You need to have an understanding of different databases such as Oracle DB, MongoDB, MySQL Server, and PostgreSQL. Also, they should have an idea about database design and writing SQL queries. Finally, you need to have a good understanding of operating systems such as Windows, Mac OS, and Linux, along with storage technologies. Talking about their salary, a database administrator in India can earn up to 4,97,000 rupees per annum. In the US, they earn around $78,000 per annum. Let's have a look at the companies hiring for database administrators. So as you see, here we have BookMyShow, Oracle, the American MNC Intel, Amazon, Robert Half, and the New York Times, to name a few. Fourth in the list of job roles, we have data engineer. A data engineer is someone who's involved in preparing data for analytical and operational uses. A data engineer transforms data into useful format for analysis. They build and test scalable big data ecosystems for businesses. A data engineer is an intermediary between a data analyst and a data scientist. Now let's jump into their responsibilities. Data engineers develop, test, and maintain architectures. They are responsible for managing, optimizing, and monitoring data retrieval, storage, and distribution throughout the organization. They discover opportunities for data acquisition, find trends in datasets, and develop algorithms to help make raw data more useful to the enterprise. Data engineers build large data warehouses using ETL for storing and retrieving data. They also recommend ways to improve data quality and efficiency, along with building algorithms to help give easier access to raw data. Data engineers often work with big data and submit their reports to data scientists for analysis purpose. They need to recommend and sometimes implement ways to improve data reliability, efficiency, and quality. Moving on to the skills of a data engineer. A data engineer should hold a bachelor's degree in computer science or information technology. They should have good hands-on experience with Python, R, and Java. Also, data engineers should be well-versed with big data technologies such as Hadoop, Apache Spark, Scala, Cassandra, and MongoDB. Data warehousing and ETL experience are essential to this position, along with in-depth knowledge of SQL and other database solutions. Basic knowledge of statistical analysis will be an advantage, along with idea about operating systems. Here is what a data engineer can earn. So in India, a data engineer can earn up to 8,85,000 rupees per annum, while they can earn around $103,000 a year in the USA. We have Capgemini, Shutterstock, the American provider of stock photography, Spotify, Accenture, Genpact, and Facebook hiring data engineers. The next exciting job role is of a data scientist. A data scientist is a professional who uses statistical methods, data analysis techniques, machine learning, and related concepts in order to understand and analyze data to draw business conclusions. They make sense to messy and unstructured data and bring value out of it. They employ techniques and theories drawn from many fields within the context of mathematics, statistics, computer science, and information science. A data scientist understands the challenges in business and comes up with the best solutions using modern tools and techniques to analyze, visualize, and build prediction models to make business decisions. Let us now look at their responsibilities in the industries. Data scientists clean, process, and manipulate data using several data analytics tools. They perform ad hoc data mining, collect large sets of structured and unstructured data from disparate sources. They design and evaluate advanced statistical models to work on big data. They also create automated anomaly detection systems and keep constant track of their performance. Data scientists interpret the analysis of big data to discover solutions and opportunities. A data scientist takes input from data analysts and engineers to formulate the results. They use visualization packages and tools to create reports and dashboards for relevant stakeholders. They also adopt new business models and approaches. Apart from this, they regularly build predictive models and machine learning algorithms. Now moving on to the skills of a data scientist. A bachelor's degree in computer science or information technology will be fine. But a master's degree in the field of data science will hold a major advantage. You also need to have a good experience in the analytics domain. You should be proficient in programming languages such as Python, Java, and C++. Knowledge of Perl will also be an advantage. Familiarity with Apache Hive, Pig, and Apache Spark is necessary along with the knowledge of Hadoop. In addition to knowing programming languages, you also need to know SQL, machine learning, and deep learning. Data visualization and BI skills are necessary for creating reports and dashboards. You should also be able to communicate and present information and ideas properly. Now talking about their salary, a data scientist in India can expect an annual salary of 10,47,000 rupees per year. Meanwhile, in the US, they can earn up to $113,000 per annum. That's a lot of money. From the many companies hiring for data scientists, here we have a few companies named. They are yet again Amazon, Citibank, Apple, Google, the Japanese electronic commerce and online retailing company Rakuten, and Facebook. And finally, we have machine learning engineer. Machine learning engineers are professionals who develop intelligent machines that can learn from vast amounts of data and apply knowledge without human intervention. They use different algorithms and statistical modeling to make sense of data. They design and develop machine learning and deep learning algorithms. Their main goal is to create self-running software. Let's have a look at the responsibilities of a machine learning engineer. Machine learning engineers research, design, and develop machine learning systems. They use exceptional mathematical skills in order to perform faster computations and work with algorithms to create sophisticated models. They perform A/B testing and use data modeling to fine-tune the results. They use data modeling and evaluation strategy to find hidden patterns and predict unseen instances. Machine learning engineers work closely with data engineers to build data pipelines and interact with stakeholders to get a clarity on the requirements. Most importantly, they analyze complex data sets to verify data quality, perform model tests and experiments, choose to implement the right machine learning algorithm, and select the right training data sets. Moving on to their skills. A machine learning engineer should have a degree in computer science and information technology. They should have an advanced degree in computer science or maths. In addition to this, they should also have experience in the same domain. They should be proficient in programming languages such as Python, R, C++, and Java. Knowledge of statistics, probability, and linear algebra is necessary as all the machine learning algorithms have been derived from mathematics. Also, having an idea of signal processing would be beneficial. Machine learning engineers need to have a good understanding of data manipulation and machine learning libraries such as NumPy, Pandas, Scikit-learn, etc. They should have good oral and written communication skills. Let us now have a look at their salary structure. A machine learning engineer earns 8 lakh rupees per annum in India. While in the US, they can earn around $114,000 a year. Now that's a whopping amount, isn't it? Let's have a look at the companies hiring machine learning engineers. So as you see, we have Amazon, Microsoft, Oracle, Salesforce, Rapido, and Accenture to name a few. That was all about the job role of a machine learning engineer. Now that we have seen the different job roles in the field of data analytics, let's also go ahead and see how an ideal resume of a data analyst should look like. Seen on your screens is a sample resume of a data analyst. You can grab some ideas from this and incorporate them in your resume. Nowadays, it's quite common to have a professional photograph of yours on the resume. You can go ahead and have that. Then your name in bold, followed by your contact details like email ID and phone number. Then moving on, you would have to write a summary. Briefly explain your current job role and what you're looking for in the future. Having a LinkedIn profile link works well these days. Employers can just go ahead and look at your profile and gauge you well. Make sure to have an active LinkedIn profile. In addition to LinkedIn profile, it's also good to have a GitHub profile link which can show your coding or other technical skills. If it's impressive enough, then a lot of times the rest of your resume is just secondary. As I mentioned, this is a resume of a data analyst. So as you can see in the summary here, we have just spoken about the basic responsibilities of a data analyst. Moving on to the experience part, you have to write the job title and below that you can mention the company and the tenure accordingly. Here you would have to give a brief description of achievements in the organization, any relevant accomplishments related to the job you're applying for, the tools and the various technologies you have worked with. So in this sample, you can see we have spoken about data visualization using R and Tableau. Next, we have spoken about how the candidate has worked with other teams for a better business outcome. Most of the data analysts use SQL and Excel to handle data for reporting and database maintenance, and we have mentioned that here as well. Do make sure that you always specify the tools you use. Then you can also mention if you have worked on improving data delivery. For example, here we have spoken about developing and optimizing SQL queries, data aggregations, and ETL to improve data delivery. Finally, you can speak a bit about your reporting skills and if needed, elaborate on it. Usually, professionals would have worked in a similar domain before becoming a data analyst. Here, we have taken the role of a statistical assistant as the first job, since it's easier for a candidate with this job role to shift into the data analytics field. Nevertheless, y'all can still mention your prior experience here, be it in any domain. Under the responsibilities for this job role, we have given basics such as coding data prior to computer entry, compiling statistics from various reports, computing and analyzing data, and finally some visualization and reporting. Moving to the education, here you can mention the name of your degree and the university name. If you have a post-graduation, well and good, you can list both the degrees here. Also, if you have any certifications, you can mention them here under the education category. Now moving to the skills. Depending on your skills and your choice, you can either shift this part to the beginning of the resume or have it here. As you see on your screens, this is just a different way of displaying your skill sets. You can have all the 5 stars colored if you are excellent in that particular tool or language. As you see, it's crystal clear as to what the candidate's strong areas are. You can have various categories like shown. For example, under software development, you can list the languages that you know and how proficient you are in those particular languages. It's clear that the candidate knows Python better than JavaScript here. So the employer gets a clear idea about the skills you possess and the depth of it. Similarly, you can mention the databases as well. The few mentioned here are more or less a requirement to become a data analyst. At least, SQL is a must. Not to forget, data visualization is also very important when it comes to the job role of a data analyst. Mention the tools you know here and similarly give yourself a rating out of 5. 5 stars shaded being the highest. Here we have mentioned Tableau and Excel, which are more than sufficient to become a data analyst. Moving to the non-technical skills, you can mention the languages you know here. Here we have taken English and German. In addition to the languages, you can also feel free to mention the extracurricular activities that you are good at. So this is how an ideal resume of a data analyst should look like. You can alter it according to your achievements, skills, and experience.
Hello everyone, we have an exciting topic for today, and that is data scientist versus data analyst. Currently, all of us are living in an information-driven world, and organizations rely on data for various decision makings. This in turn provides a lot of job opportunities for candidates who can play with data. Out of the many job roles in the field of data science, the 2 popular ones are that of a data scientist and a data analyst. Haven't we all wondered at some point as to what the exact difference is between these 2 job roles? Or wait, are they the same? Well, they differ in various ways, and you will see how in this video. We will start off by looking at the job descriptions of both the data scientist and the data analyst. Then we will look at their responsibilities and skill set. We will also have a look at their salary structure and the various companies hiring for these professionals. So without further ado, let's get started. Let's have a look at the job description now. A data scientist is a professional who uses different statistical methods, data analysis techniques, and machine learning in order to understand and analyze data in order to arrive at business conclusions. They proactively fetch information from a plethora of sources and analyze it for better understanding about how the business performs, and they also build AI tools that automate certain processes within the company. They derive meaning out of messy and unstructured data. A data scientist is usually a senior-most member in the team. Moving to the description of data analyst, a data analyst is responsible to collect, process, and perform analysis on large data sets. They deal with data handling, data modeling, and reporting. They are sometimes the entry-level members into the data analytics team. They bring technical expertise to ensure the quality and accuracy of the data, then process, design, and present it in ways to help people, businesses, and organizations make better decisions. After a few years of experience, data analysts can move into the roles of a data engineer and a data scientist. Now that we have understood the job descriptions, let's go ahead and understand the various roles and responsibilities of a data scientist and a data analyst. Firstly, data scientists are responsible for performing cleaning, processing, and manipulation of data using several data analytics tools. They also perform ad hoc data mining and collect large sets of structured and unstructured data from a number of sources. Secondly, data scientists interpret the data using various statistical methods. They design and evaluate advanced statistical models to work on big data. Thirdly, data scientists regularly build predictive models and machine learning algorithms to work on vast volumes of data. Lastly, data scientists use visualization packages and tools to create reports and dashboards for relevant stakeholders. They also work with data analysts and data engineers to formulate the analysis results. Let's now have a look at the various responsibilities of a data analyst. The first responsibility of a data analyst is to recognize and understand the company's goal. This in turn helps in streamlining the whole analysis process. They are required to assess the available resources, comprehend the business problem, and gather the right set of data. This step is done by collaborating with different team members such as data scientists, business analysts, and programmers. They gather data from various databases and warehouses through querying. They write complex SQL queries and scripts to gather and extract information. Data analysts also filter and clean data to get the required information. They are responsible for data mining as well. Data is mined from various sources and then organized in order to obtain new information from it. Data analysts identify and analyze trends in complex data sets using various statistical tools. A data analyst is also responsible for creating summary reports for the leadership team so that they can make timely decisions. Data analysts use multiple data visualization tools for achieving this. In order to achieve all the above-mentioned responsibilities, data scientists and data analysts are required to possess a rich skill set. Let's now have a look at few of the most important skills required to back the position of a data scientist. The basic requirement to become a data scientist is that you must have a bachelor's degree in computer science or information technology. But a master's degree in the field of data science will be a lot more beneficial. You also need to have a good experience in the analytics domain. As I mentioned before, this role is a senior role, and to get here, the right amount of experience is a must. Let's have a look at the tools you need to know. Knowledge of Microsoft Excel is good. It is one of the most basic requirements. Speaking of programming languages, you should be good at Python, C++, and Java. Knowledge of Perl is a brownie point. You should also be proficient in SQL. As we discussed earlier, data scientists work on building machine learning algorithms. Hence, you need to have a good knowledge of machine learning and deep learning. Familiarity with Apache Spark, Apache Hive, and Apache Pig is necessary along with the knowledge of Hadoop. Data visualization and BI skills are necessary for creating reports and dashboards. You should also be able to communicate and present information and ideas clearly. So these are the skills required to become a data scientist. If you want to explore the role of a data analyst, then you should hold a degree in any relevant field, be it engineering and computer science, information technology, or electrical engineering. You can also be a graduate in statistics or economics. Moving on to the tools, once again, you should be familiar with Microsoft Excel. The next important skill is that you should have good hands-on experience with programming languages such as Python, R, and JavaScript. This would help you write programs to solve complex problems. You should also have a good knowledge of statistical and data analytics tools such as SAS Miner and SSAS. You must be able to write various SQL queries and procedures. In addition to these, you must have a strong understanding of statistics and machine learning algorithms. These include concepts such as hypothesis testing, probability distributions, and various classification and clustering techniques. Most importantly, a data analyst should be able to create visually appealing reports with the help of charts and graphs using several data visualization tools such as Power BI and Tableau. They must possess good presentation skills as well in order to convey their ideas to the clients and stakeholders in a better way. So these are the skills that are required to become a data analyst. Let's now have a look at the annual salary range of a data scientist and a data analyst both in the US and in India. In the United States, a data scientist can earn a minimum salary of $61,000 to a maximum of $136,000 per year. Meanwhile, in India, a data scientist can earn a minimum salary of 3,47,000 rupees to a maximum of 2 million rupees per annum. A data analyst in the United States can earn a minimum salary of $43,000 to a maximum of $85,000 per year. In India, you can earn anywhere between 1,98,000 rupees to 9,24,000 rupees per annum. Let's now take a look at the various companies hiring data scientists and data analysts. Here we have Amazon, the internet and search engine giant Google, Deloitte, the American multinational technology company Microsoft, then we have Apple and the American social media web and mobile application company Pinterest hiring data scientists. From the many companies hiring data analysts, here we once again have Amazon, then we have the popular retail company Walmart, Robert Half, and AT&T. Next we have social media firms Facebook and Twitter. As you might have heard of the term data never sleeps, well, it surely doesn't, and not only that, but it also brings in a number of job opportunities with it. The job growth in this domain is limitless, and data will only continue to grow. Let's have a look at a few of the stats now. Well, IBM had predicted that by this year, that is 2020, the number of job listings in the field of data science and analytics will increase by 3,64,000. And we had the US Bureau of Labor Statistics predicting that there will be a rise in the data science needs, and this in turn will create 11.5 million job openings by 2026. Now that's a big number, isn't it? And if you are aspiring to become a data scientist, then you are on the right path as there is a huge demand for this role. According to Deloitte, the United States is projected to face a shortfall of 250,000 data scientists by 2024. That's barely just in 4 more years. All these stats prove that the job demand in the field of data science and data analytics is here to stay. Professionals belonging to this domain are in high demand all across the globe. Now let's have a look at the Google search trends for data scientists and data analysts. As you see, the blue color depicts data scientists and the red data analysts. Both the search trends go hand in hand, and over time the search term data analyst is higher, but the search term of that of a data scientist is experiencing a steady rise. Let's have a look at the worldwide YouTube search trend as well. As you can see on your screens, it looks like people are more keen on exploring the job role of a data scientist, and looks like they want to learn more about the job role of a data scientist compared to that of a data analyst. Nevertheless, the search term data analyst is also right there in the competition.
Now Richard will help us understand the top data analyst interview questions.
Today we're going to jump into some common questions you might see on NumPy arrays and Pandas data frames in the Python, along with some Excel, Tableau, and SQL. Let's start with our first question. What is the difference between data mining and data profiling? It's real important to note that data mining is a process of finding relevant information which has not been found before. It is a way in which raw data is turned into valuable information. You can think of this as anything from the sales stats and from their SQL server all the way to web scraping and Census Bureau information. Where the heck do you mine it from? Where do you get all this data and information? Then we look at data profiling. It is usually done to assess a data set for its uniqueness, consistency, and logic. It cannot identify incorrect or inaccurate data values. So if somebody has a statistical analysis on one side and they're doing you might the wrong data to then program your data setup. So you got to be aware that when you're talking about data mining, you need to look at the integrity of what you're bringing in, where it's coming from. Data profiling is looking at it and saying, hey, how is this going to work? What's the logic? What's the consistency? Is it related to what I'm working with? Define the term data wrangling and data analytics. Data wrangling is a process of cleaning, structuring, and enriching the raw data into a desired usable format for better decision making. And you can see a nice chart here with our Discover It. We structure the data how we want it. We clean it up, get rid of all those null values. We enrich it, so we might take and reformat some of the settings. Instead of having 5 different terms for height of somebody, in American, English, or whatever, we clean some of that up, and we might do a calculation and bring some of them together. And validate. I was just talking about that in the last one. You need to validate your data. Make sure you have a solid data source. And then, of course, it goes into the analysis. Very important to notice here in data wrangling, 80% of data analytics is usually in this whole part of wrangling the data, getting it to fit correctly. And don't confuse that with data cooking, which is actually when you're going into neural networks, cooking the data so it's all between 0 and 1 values. What are common problems that data analysts encounter during analysis? Handling duplicate and missing values, collecting the meaningful right data the right time, making data secure and dealing with compliance issues, handling data purging and storage problems. Again, we're talking about data wrangling here. 80% of most jobs are in wrangling that data and getting it in the right format and making sure it's good data to use. Number 4, what are the various steps involved in any analytics project? Understand the problem. We might spend 80% doing wrangling, but you better be ready to understand the problem, because if you can't, you're going to spend all your time in the wrong direction. This is probably the most important part of the process. Everything after it falls in, and then you can come back to it. 2, data collection, data cleaning. Number 3, 4, data exploration analysis, and 5, interpret the results. Number 5 is a close second for being the most important. If you can't interpret what you bring to the table to your clients, you're in trouble. So when this question comes up, you probably want to focus on those 2, noting that the rest of it does, 80% of the work is in 2, 3, and 4, while 1 and 5 are the most important parts. Which technical tools have you used for analysis and presentation purposes? Being a data analyst, you are expected to have knowledge of the below tools for analysis and presentation purposes. There's a wide variety out there. SQL Server, MySQL,
You have your Excel, your SPSS, which is the IBM platform, Tableau, Python. You have all these different tools in here. Now, certainly a lot of jobs are going to be narrowed in on just a few of these tools. Like, you're not going to have a Microsoft SQL Server and MySQL Server, but you better understand how to do basic SQL polls, and also understanding Excel and how the different formats for column and how to get those set up. Number 6, what are the best practices for data cleaning? This is really important to remember to go through this in detail. These always come up because 80% of most data analysis is in cleaning the data up. Make a data cleaning plan by understanding where the common errors take place and keep communications open. Identify and remove duplicates before working with the data. This will lead to an effective data analysis process. Focus on the accuracy of the data, maintain the value types of data, provide mandatory constraints, and set cross-field validation. Standardize the data at the point of entry so that it is less chaotic, and you will be able to ensure that all the information is standardized, leading to fewer errors on entry. Number 7, how can you handle missing values in a data set? Listwise deletion. In listwise deletion method, entire record is excluded from analysis if any single value is missing. Sometimes we're talking about records. Remember, this could be a single line in a database. So if you have your SQL comes back and you have 15 different columns, every one of those that has a missing value, you might just drop it just to make it easy because you already have enough data to do the processing. Average imputation. Use the average value of the responses from the other participants to fill in the missing value. This is really useful, and they'll ask you why these are useful, I guarantee it. If you have a whole group of data that's collected and it doesn't have that information in it, at that point you might average it in there. Regression substitution. You can use multiple regression analysis to estimate a missing value. That kind of goes with the average imputation input. Regression model means you're just going to actually generate a prediction as to what you think that value should be for those people based on the ones you do have. Multiple imputation. So when we talk about multiple inputs, it creates plausible values based on the correlations for the missing data, and then average the simulated data sets by incorporating random errors in your predictions. What do you understand by the term normal distribution? And the second you hear the word normal distribution, should be thinking a bell curve like we see here. Normal distribution is a type of continuous probability distribution that is symmetric about the mean, and in the graph, normal distribution will appear as a bell curve. The mean, median, and mode are equal. That's a quick way to know if you have normal distribution, is you can compute mean, median, and mode. All of them are located at the center of the distribution. 68% of the data lies within one standard deviation of the mean. 95% of the data falls within 2 standard deviations of the mean. 99.7% of the data lies within 3 standard deviations of the mean. What is time series analysis? Time series analysis is a statistical method that deals with ordered sequence of values of a variable of equally spaced time intervals. Time series data on a COVID-19 cases. And you can see we're looking at by days, so our space is of days, and each day goes by. If we take and graph it, you can see a time series graph always looks really nice if you have like 2 different, in this case we have the United States going over there. I'd have to look at the other setup in there, but they picked a couple different countries. And it's time sensitive. With the next result is based on what the last one was. COVID's an excellent example of this. Anytime you do any word analytics where you're figuring out what someone's saying, what they said before makes a huge difference as to what they're going to say next. Another form of time series analysis. 10. How is joining different from blending in Tableau? So now we're going to jump into the Tableau package. Data joining. Data joining can only be done when the data comes from the same source. Combining 2 tables from the same database or 2 or more worksheets from the same Excel file. All the combined tables or sheets contains common set of dimensions and measures. Data blending. Data blending is used when the data is from 2 or more different sources. Combining the Oracle table with the SQL server, or 2 sheets from Excel, or combining Excel sheet and Oracle table. In data blending, each data source contains its own set of dimensions and measures. How is overfitting different from underfitting? Always a good one. Overfitting. Probably the biggest danger in data analytics today is overfitting. Model trains from the data too well using the training set. The performance drops significantly over the test set. It happens when the model learns the noise and random fluctuations in the training data set in detail. And again, the performance drops way below what the test set has. The model neither trains the data well nor can generalize to new data. Performs poorly both on train and the test set. Happens when there is less data to build and an accurate model, and also when we try to build a linear model with a nonlinear data. In Microsoft Excel, a numeric value can be treated as a text value if it precedes with an apostrophe. Definitely not an exclamation. If you're used to programming in Python, you'll look for that hash code, and not an amber sign. And we can see here, if you enter the value 10 into a field, but you put the apostrophe in front of it, it will read that as a text, not as a number. What is the difference between count, count A, count blank, and count if in Excel? We can see here when we run in just count, D1 through D23, we get 19. And you'll notice that there is 19 numbers coming down here. And so it doesn't count the cost of each, which is the top bracket, and it doesn't count the blank spaces either with the straight count. When you do a count A, you'll get the answer is 20. So now when you do count A, it counts all of them, even the title cost of each. When you do count blank, we'll get 3. Why? There's 3 blank fields. And finally, the count if. If we do count if of E1 to E23 is greater than 10, there's 11 values in there. Basic counting of whatever's in your column, pretty solid on the table there. Explain how VLOOKUP works in Excel. VLOOKUP is used when you need to find things in a table or arrange by row. The syntax has 4 different parts to it. We have our lookup value, that's a value you want to look up. We have our table array, the range where the lookup value is located, column index number, the column number and range that contains the return value, and the range lookup. Specify true if you want an approximate match or false if you want an exact match of the return value. So here we see VLOOKUP F3 A2 to C8 2, 0 for prints. Now they don't show the F3. F3 is the actual cell that prints is in. That's what we're looking at is F3. So there's your prints. He pulls in from F3. A2 to C8 is the data we're looking into. And then number 2 is a column in that data. So in this case, we're looking for age. And we count name as 1, age as 2. Keep in mind this is Excel versus a lot of your Python and programming languages where you start at 0. In Excel, we always look at the cells as 1, 2, 3. So 2 represents the age. 0 is false for having an exact matchup versus 1. We don't actually need to worry about that too much in this. 0 or 1 would work with this example. And you can see with the Angela lookup, again, her name would be in the F column number 4. That's what the F4 stands for, is where they pulled Angela from. And then you have A1 to C8, and then we're looking at number 3. So number 3 is height, name being 1, age 2, and then height 3. And you'll see here it pulls in her height 5.8. So we're going to jump over to SQL. How do you subset or filter data in SQL? To subset or filter data in SQL, we use where and having clause. And you can see we have a nice table on the left where we have the title, the director, the year, the duration. We want to filter the table for movies that were directed by Brad Bird. Why? Just because we want to know what Brad Bird did. So we're going to do select star. You should know that the star refers to all. In this case, what are we going to return? We're going to return all title, director, year, and duration. That's what we mean by all. From movies, movies being our table, where director equals Brad Bird. And you can see he comes back and he did The Incredible on Ratatouille. To subset or filter data SQL, we can also use the where and having clause. So we're going to take a closer look at the different ways we can filter here. Filter the table for directors whose movies have an average duration greater than 115 minutes. So there's a lot of really cool things into this SQL query, and these SQL queries can get pretty crazy. Select director sum duration as total duration, average duration as average duration from movies, group by director having average duration greater than 115. So again, what are we going to return? We're going to return whatever we put in our select, which in this case is director. We're going to have total duration, and that's going to be the sum of the duration. We're going to have the average duration, average underscore duration, which is going to be the average duration on there. And then we, of course, go ahead and group by director. And we want to make sure we group them by anyone that has having an average duration greater than 115. These SQL queries are so important. I don't know how many times the SQL comes up, and there's so many different other languages, not just MySQL and not Microsoft SQL, but in addition to that, where the SQL language comes in, especially with Hadoop and other areas. So you really should know your basic SQL. Doesn't hurt to get that little cheat sheet and glance over it and double check some of the different features in SQL. What is the difference between where and having clause in SQL? Where clause works on row data. In where clause, the filter occurs before any groupings are made. Aggregate functions cannot be used. So the syntax is select your columns from table where what the condition is. Having clause works on aggregated data. Having is used to filter values from a group. Aggregate functions can be used, and the syntax is select column names from table where the condition is, grouped by, having a condition ordered by column names. What is the correct syntax for reshape function in NumPy? So we're going to jump to the NumPy array program. And what you come up with is you have, in this case, it'd be numpy.reshape. A lot of times you do an import numpy as np, reshape, and then your array, and the new shape. And you can see here as the actual example comes in, the reshape is A, and we're going to reshape it in 2, 5 setups. And you can see the printout in there that prints in 2 rows with 5 values in each one. What are the different ways to create a data frame in Pandas? Well, we can do it by initializing a list. So you can import your pandas as PD, very common. Data equals Tom 30, Jerry 20, Angela 35. We'll go ahead and create the data frame, and we'll say pd.dataframe is the data, columns equals name and age. So you can designate your columns. You can also designate index in there. You should always remember that the index, in this case, maybe you want the index instead of 1, 2 to be the date they signed up, or who knows, whatever. And you can see right there, it just generates a nice pandas data frame with Tom, Jerry, and Angela. Another way you can initialize a data frame is from dictionary. You can see here we have a dictionary where the date equals name, Tom, Jerry, Angela, Mary. Age is 20, 21, 19, 18. And if we do a df pd.data frame on the data, you'll get the same kind of setup. You get your name, age, Tom, Jerry, Angela, and Mary. Write the Python code to create an employee's data frame from the emp.csv file and display the head and summary of it. To create a data frame in Python, you need to import the pandas library and use the read CSV function to load the CSV file. And here you can see we have import pandas as PD, employees, or the data frame employees, equals pd.readcsv, and then you have your path to that CSV file. There's a number of settings in the read CSV where you can tell it how many rows are the top index. You can set the columns in there. You can have skip rows. There's all kinds of things. You can also go in there and double check with your read CSV, but the most basic one is just to read a basic CSV. How will you select the department and age columns from an employee's data frame? So we have import pandas as PD. You can see we have created our data. We will go ahead and create our employees PD data frame on the left. And then on the right, to select department and age from the data frame, we just do employees, and then you put the brackets around it. Now, if you're just doing one column, you could do just department. But if you're doing multiple columns, you got to have those in a second set of brackets. So it's got to be a reference with a list within the reference. What is the criteria to say whether a developed data model is good or not? A good model should be intuitive, insightful, and self-explanatory. Follow the old saying, KISS, keep it simple. The model developed should be able to easily consumed by the clients for actionable and profitable results. So if they can't read it, what good is it? A good model should easily adapt to changes according to business requirements. We live in quite a dynamic world nowadays, so that's pretty self-evident. And if the data gets updated, the model should be able to scale accordingly to the new data. So you have a nice data pipeline going where when you get new data coming in, you don't have to go and rewrite the whole code. What is the significance of exploratory data analysis? Exploratory data analysis is an important step in any data analysis process. Exploratory data analysis, EDA, helps to understand the data better. It helps you obtain confidence in your data to a point where you're ready to engage a machine learning algorithm. It allows you to refine your selection of feature variables that will be used later for model building. You can discover hidden trends and insights from the data. How do you treat outliers in a data set? An outlier is a data point that is distant from other similar points. They may be due to variability in the measurement or may indicate experimental errors. One, you can drop the outlier records. Pretty straightforward. You can cap your outliers data, so it doesn't go past a certain value. You can assign it a new value. You can also try a new transformation to see if those outliers come in if you transform it slightly differently. Explain descriptive, predictive, and prescriptive analytics. Descriptive provides insights into the past to answer what has happened. Uses data aggregation and data mining techniques. Examples: an ice cream company can analyze how much ice cream was sold, which flavors were sold, and whether more or less ice cream was sold than before. Predictive understands the future to the answer, what could happen. Uses statistical models and forecasting techniques. Example: predicts the sale of ice creams during the summer, spring, and rainy days. So this is always interesting because you have your descriptive, which comes in, and your businesses are always looking to know what happened. Hey, did we have good sales last quarter? What are we expecting next quarter in sales? And we have a huge jump when we do prescriptive. Suggest various courses of action to answer what should you do. Uses optimization and simulation algorithms to advise possible outcomes. Example: lower prices to increase sale of ice creams, produce more or less quantities of certain flavor of ice cream. And we can certainly, today's world with the COVID virus, because we had that on our earlier graph, you could see that as a descriptive. What's happened? How many people have been infected? How many people have died in an area? Predictive. Where do we predict that to go? Do we see it going to get worse? Is it going to get better? What do we predict that we're going to need in hospital beds? And prescriptive. What can we change in our setup to have a better outcome? Maybe if we did more social distancing, if we tracked the virus. How do these different things directly affect the end, and can we create a better ending by changing some underlying criteria? What are the different types of sampling techniques used by data analysts? Sampling is a statistical method to select a subset of data from an entire data set. Population, to estimate the characteristics of the whole population. One, we can do a simple random sampling. So we can just pick out 500 random people in the United States to sample them. You call it a population. In regular data, we also call that a population, just because that's where it came from, was mainly from doing census. Systematic sampling, cluster sampling, stratified sampling, and judgment or purposive sampling. Then we have our systematic sampling. That's where you're doing like using 1, 5, 10, 15, 20. Use a very systematic approach for pulling samples from the setup. Cluster sampling. That's where we look at it and we say, hey, some of these things just naturally group together. If you were talking about population, which is really a nice way of looking at this, cluster sampling would be maybe by zip code. We're going to do everybody's zip code and just naturally cluster it that way. Stratified sampling would be more looking for shared things the group has, like income. So if you're studying something on poverty, you might look at their naturally group people based on income to begin with, and then study those individuals in the income to find out what kind of traits they have. And then judgmental. That is where the researcher very carefully selects each member of their own group. So it's very much based on their personal knowledge. Jumping on to 26, what are the different types of hypothesis testing? Hypothesis testing is a procedure used by statisticians and scientists to accept or reject statistical hypothesis. We start with the hypothesis testing. We have null hypothesis and alternative hypothesis. On the null hypothesis, it states that there is no relation between the predictor and the outcome variables in the population. It is denoted by H0. Example, there is no association between patients, BMI, and diabetes. Alternative hypothesis, it states there is some relation between the predictor and outcome variables in the population. It is denoted by H1. Example, there could be an association between patients' BMI and diabetes. And that's the body mass index, if you didn't catch the BMI and you're not in medical. Describe univariate, bivariate, and multivariate analysis. A univariate analysis, it is the simplest form of data analysis where the data being analyzed contains only one variable. An example is studying the heights of players in the NBA. Because it's so simple, it can be described using central tendencies, dispersion, quartiles, bar charts, histograms, pie charts, frequency distribution tables. The bivariate analysis, it involves analysis of two variables to find causes, relationships, and correlations between the variables. Example, analyzing sale of ice creams based on the temperature outside. Bivariate analysis can be explained using correlation coefficients, linear regression, logistic regression, scatter plots, and box plots. And multivariate analysis, it involves analysis of three or more variables to understand the relationship of each variable with the other variables. Example, analyzing revenue based on expenditure. So if we have our TV ads, we have our newspaper ads, our social media ads, and our revenue, we can now compare all those together. The multivariate analysis can be performed using multiple regression, factor analysis, classification and regression trees, cluster analysis, principal component analysis, clustering bar chart, dual axis chart. What function would you use to get the current date and time in Excel? In Excel, you can use the today and now function to get the current date and time. And you can see down here with the two examples where just equals today or equals now. Using the SUMIFS function in Excel, find the total quantity sold by sales representatives whose names start with A and the cost of each item they have sold is greater than 10. And you can see here on the left we have our actual table, and then we want to go ahead and SUMIFS. So we want the E2 through E20, B2 through B20 greater than 10. And this basically is just saying, hey, we're going to take everything in the E column and we're going to sum it up, but only those objects where the D column is greater than 10. That's what that means there. Is the below query correct? If not, how will you rectify it? Select customer ID, year, order date as order year from order where order year is greater than or equal to 2016. And hopefully you caught it right there. It's in the devil's in the details. We can't not use the alias name while filtering data using the where clause. So the correct format is all the same except for where it says where the year order date is greater than or equal to 16 versus using the order year, which we assign under the select setup. How are union, intersect, and except used in SQL? The union operator is used to combine the results of two or more select statements. And you can see here we have select star from region 1. We're going to make a union with select star from region 2. And it basically takes both these SQL tables and combines them to form a full new table on there. So that's your union as we bring everything together. When we look at the intersect operator, returns the common records that are the result of the two or more select statements. So you can see here we select star from region 1, intersect, select star from region 2, and we come up with only those records that are shared, that have the same data in them. And hopefully you jumped ahead to the except. The except operator returns the uncommon records that are the result of two or more select statements. So these are the two records, or the records that are not shared between the two databases. Using the product price table, write an SQL query to find the record with the fourth highest market price. So here we have a little bit of a brain teaser. They're always fun. And the first thing we want to do is we're going to go ahead and if you look at the script on the left, we really want the fourth one down. So we're going to select the top 4 from product price. But we're going to order it by market price descending. SP ordered by market price ascending. So what we do is we take the top 4 of the market price ascending, and that's going to give us the 4 greatest values. And then we're going to reverse that order and do descending. And we're going to take the top one of that, which is going to give us the lowest value, which will be the 4th greatest one in the list. From the product price table, find the total and average market price for each currency where the average market price is greater than 100 and currency is in the INR or the AUD. So INR or AUD, India Rupee or Australia dollar. You can see over here the SQL query. If you had trouble putting this together, you might actually do some of it in reverse. And you can see right here where the average market price is greater than 50. Remember, we use having, not where, at the end because it's part of the group. So group by currency, because we want those two currencies. And we want the currency India Rupee, the INR or the AUD. And as you keep going backwards, we're actually going to be selecting the currency, the sum of the market price as total price, and the average market price as average price. So there's our select. It's going to come from the product price, which is just our table over there, and then we have where our currency is in. And like I said, you can put it together however you want, but hopefully you got to the end there. So this question will test your knowledge in Tableau, exploring the different features of Tableau, and creating a suitable graph to solve a business problem. And of course, Tableau is very visual in its use, so it's very hard to test it without actually just getting your hands on. And if you can't visualize some of this and how to do it, then you should go back and refresh yourself. Using the sample superstore dataset, create a view to analyze the sales, profits, and quantities sold across different subcategories of items present under each category. So the first step is to go ahead and load the sample superstore dataset. So make sure you know how to load the sample, the superstore dataset. That's underneath either the connect button in the upper left or the Tableau icon up there, and be able to pull in the data set. And then once you've done that, you just drag the category and subcategory on rows and salaries onto columns. It will result in a horizontal bar chart. So in this one, we're just going to drag profit onto color and quantity onto label. Sort the sales axes in descending order of sum and sales within each subcategory. And if you're at home doing this, you'll see that chairs under furniture category had the highest sales and profit, while tables had the lowest profit. For office supplies, subcategory binders made the highest profit, even though storage had the highest sales. Under technology category, copiers made the highest profit, though it was the least amount of sales. Let's work to create a dual axis chart in Tableau to present sales and profits across different years using sample superstore dataset. Load the orders sheet from the sample superstore dataset. Drag the order data field from the dimensions onto columns and convert it into continuous month. Drag cells onto rows and profits to the right corner of the view until you see a light green rectangle. One of those things, if you haven't done this hands-on, you don't know what you're doing, you're going to run into a bind, so you're going to be just kind of dropping it and wondering what happened. Synchronize the right axes by right-clicking on the profit axis. And then let's finalize it by going under the marks card, change some cells to bar and some profit to line, and adjust the size. And then we have a nice display that we can either print out or save and send off to the shareholders. Let's go ahead and do one more Tableau. Design a view in Tableau to show state-wise sales and profits using the sample Superstore dataset. In here you go ahead and drag the country field onto the view section and expand it to see the states. Drag the states field onto size and profit onto color. Increase the size of the bubbles, add a border and a halo color. States like Washington, California, and New York have the highest sales and profits, while Texas, Pennsylvania, and Ohio have a good amount of sales but the least amount of profits. We'll go ahead and skip back to Python NumPy. Suppose there is an array number equals NP, or NumPy if you're using NumPy, depending on how you set it up, dot array, and we just have 1 to 9 broken up into 3 groups. Extract the value 8 using 2D indexing. So you can see on the left we have our import NumPy as NP, number equals our NP array. If we print the number, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Since the value 8 is present in the second row and first column, we use the same index position and pass it to the array. And you just have number 2, 1, and you get 8. And remember, we're in Python, so you start at 0, not 1 like you do in Excel. Always gets me if I'm working between Excel and Python, where I just kind of flip, and usually it's the Excel that messes up because I do a lot more programming. Suppose there's an array that has values 0, 1, all the way up to 9. How will you display the following values from the array? 1, 3, 5, 7, 9. So first of all, we go ahead and create the array, np.arange of 10, which goes from 0 to 9, because there's 10 numbers in it, but we don't include the 10. We print it out. The first thing you want to do is, what's going on here with 1, 3, 5, 7, 9? Well, if we divide by 2, there's going to be a remainder equal to 1. And then from Python, remember that if you use the percentage sign, you get the remainder on there. So the remainder is 1. And then you have your NumPy array, and then we just want to do a logical statement of all values that have a remainder of 1, and that generates our nice 1, 3, 5, 7, 9. There are 2 arrays, A and B. Stack the arrays A and B horizontally. Boy, these horizontal vertical questions will get you every time. And in NumPy, we go ahead and we've created 2 different arrays over here, A and B. The first one is your concatenate, np.concatenate A and B on axes equal 1. That is the same as hstack. And in the back end, they're still identical. They run the same. That's all hstack is, a concatenate axes equals 1. How can you add a column to a pandas data frame? Suppose there's an imp data frame that has information about few employees. Let's add address column to that data frame. And you can see on the left we have our basic data frame. You should know your data frames very well. Basically it looks like an Excel spreadsheet. As you come over here, it's really simple. You just do df of address equals the address once you've assigned values to the address. Using the below given data, create a pivot table to find the total cells made by each sales representative for each item. Display the cells as a percentage of the grand total. So we're back in Tableau. Select the entire table range, click on Insert tab, and choose Pivot Table. Select the table range and the worksheet where you want to place the pivot table. It will return a pivot table where you can analyze your data. Drag the cell total on the values in sales rep and item onto row labels. It will give the sum of the sales made by each representative for each item they have sold. And finally, right-click on Sum of Cell Total and expand Show Values as to select percentage of grand total. Real important just to understand what a pivot table is. We're just pivoting it from rows and columns and switching this direction on there. And finally, we have our final pivot table, and you can see the values, roles, and sum of total cell. So we're going to go ahead and take a product table. This is off of an SQL, so we're going to do some SQL here. And we're going to use the product and sales order detail table, find the products that have total units sold greater than 1.5 million. And here's our sales order detail table. So we have a product table and a sales order detail table, two separate tables in the database. And what we're going to do is put together the SQL query. We want to select PP name, sum, SOD, unit price as cells. And then we have our pp.product ID from production product as pp inner join, cells.sales order detail as SOD on pp product ID equals SOD.product ID group by pp.name, comma pp.product ID having a sum of SOD.unit price greater than the 150 million there. That's a mouthful. And again, these SQL queries, they start looking really crazy until you just break them apart and do them step by step. And what we're looking for is the inner join and how did you do the group by. That's really what they know. How do you do this inner join? This comes up so much in SQL. How do you pull in the ID from one chart and the information from another chart and the sum totals on that chart? How do you write a stored procedure in SQL? Let's create a stored procedure to find the sum, the squares of the first n natural numbers. So here we have our formula, n times n plus 1 times 2n plus 1 over 6. And you can see from the command prompt or the setup you have, depending on what your login is, the command is create procedure square sum 1. Declare a variable at n of integer as begin, and then we're going to declare the sum of integer, set sum equals n times n plus 1 plus 2 times n plus 1 over 6. And then of course we can go ahead and print those out. Print first cast ampersand n, or our variable, as a variable character 20 natural numbers. Print the sum of the square is cast the at sum as variable character 40 end. And then we do the output, display the sum of the square for first 4 natural numbers. We have execute square sum 1, and then we're going to put in 4, and you can see here where it brings up the first 4 natural numbers. Sum of square is 30. Write a store procedure to find the total even number between two user-given numbers. A couple of things to note here. First, we go ahead and create our procedure. You have your two different variables, the n1, n2. And we go ahead and begin. We're going to declare our variable count as an integer. We're going to set count equal to 0. And then we have while n is less than n2. We're going to begin. And if n1 remainder 2 equals 0, so we're going to divide it by 2, even number, begin. We're going to set the count equal to count plus 1. We're going to print even number plus cast n as a variable character 10 for printing. Count is plus cast variable count as variable character 10 end. Else print odd number plus cast variable number 1 as variable character 10. And then we go ahead and set the increment our variable 1 up 1. So it'll go from n1 all the way to n2. And it'll print the total number of even numbers. And you can see here we went ahead and executed it. We're going to count the even numbers between 30 and 45. And you can just see it goes all the way down to 8. What is the difference between tree maps and heat maps in Tableau? Now, if you've worked in Python and other programmings, you should automatically know what a heat map is. But a tree map are used to display data in nested rectangles. You use dimensions to define the structure of the tree map and measure to define the size or color of individual rectangles. Tree maps are a relatively simple data visualization that can provide insight in a visually attractive format. And again, you can see the squares over here. This is our tree map over here with each block also has its information inside of its different blocks. A heat map helps to visualize measures against dimensions with the help of colors and size to compare one or more dimensions and up to 2 measures. The layout is similar to a text table with variations in values encoded as colors. In heat map, you can quickly see a wide array of information. And in this one, you can see they use the colors to denote one thing and the size of the little square to denote something else. A lot of times you can even graph this into a 3-dimensional graph with other data so it pops out. But again, a heat map is the color and the size. Using the sample superstore dataset, display the top 5 and bottom 5 customers based on their profit. So you start by dragging the customer name field onto rows and profit on columns. Right-click on the customer name column to create a set. Give a name to the set and select Top Tab to choose top 5 customers by sum profit. Similarly, create a set for the bottom 5 customers by sum profit. Select both the sets, right-click to create a combined set. Give a name to the set and choose all members in both sets. And then you can drag top and bottom customer sets onto the filters and profit field onto color to get the desired results. As we get down to the end of our list, we're going to try to keep you on your toes. We're going to skip back to NumPy. How to print 4 random integers between 1 and 15 using NumPy. To generate random numbers using NumPy, we use the random integer function. And you can see here we did the import NumPy as np, random arrangement equals np.random.random integer 1 through 15 of 4. From the below data frame, going to jump again on you, now we're into pandas. How will you find the unique values for each column and subset the data for age less than 35 and height greater than 6? To find the unique values and the number of unique elements, use the unique and the InUnique function. You can see here we just did df height, so we're selecting just the height column and we want to look for the unique. That returns an array, where InUnique, if we do that on the height or the age, will return just the number of unique values. And then we can do a subset the data for ages less than 35 and height greater than 6. So if we look over here, we have a new df. Remember, this is going to be taking slices of our original data frame. It doesn't actually change the data frame. So our new df equals the data frame, or df, the data frame where age is less than 35 and the height is greater than 6. And in case you're not using Tableau, which has a lot of its own different mapping programs in there, make sure you understand how to use the basics of Matplot library. Plot a sign graph using NumPy and Matplot library in Python. And the way we did this is we went ahead and generated an x. We know our y equals np.sign of x. If you print out x, you'll see a whole value here. Our Matplot library PyPlot as PLT. If you are working in Jupyter Notebook, make sure you understand the Matplot library inline, that little percentage sign Matplot library inline. That prints it on the page in the Jupyter Notebook. The newer version of Jupyter Notebook or Jupyter Labs automatically does that for you, but I usually put it in there just in case I end up on an older version. If you print y, you can see here we have our different y values and our different x values. You simply put in plt.plot xy and do a plot show. And before we go, let's get one more in. We're going to do a pandas using the below pandas data frame. Find the company with the highest average sales, derive the summary statistics for this sales column, and transpose these statistics. That's a mouthful. And just like any of these computer problems, break it apart. So first of all, we're looking for the highest average sales. So group the company column and use the mean function to find the average sales. And you can see here by company equals df.groupBy company. Once we've done that, using the describe function, we can now go ahead and look at the summary of statistics on here. Use the describe function to find the summary. So by company, those are groups. We're just going to describe them. And you could actually bundle those together if you wanted and just do them all in one line. So here we go, by company.describe. You can see we have a nice breakout. Always good to remember. Whether you're using any of the packages, whether it's Tableau or Pandas, in Python or even R or some other package, being able to quick look and describe your data is very important. And then we can go ahead and just do a basic apply a transpose function over the describe method to transpose the statistics. All we've done here is flip the index with the column names, but if you're following the numbers, a lot of times it's easier to follow across one line, or maybe you want to average out the count, or there's all kinds of different reasons to do that.
With that, we have come to the end of this video tutorial on data analytics full course. I hope it was interesting and informative. If you have any questions, then please put it in the comment section of the video. Don't forget to subscribe to our YouTube channel. Thanks for watching. Stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.